Okay, we should be live. Let's see. Let's see. How's the sound? Please let me know how the sound is. I'm checking it also on my own, but it helps if you let me know. I don't hear things all the time. So, but this should be a great stream tonight. I feel a little bit out of practice. I always do after taking a couple, even like a 1 week break. I feel like, I don't know, feel out of practice. But I switched to the old thumbnail for now. I don't know how, I just don't like the new one. We need a new one that I like. So if you have any ideas, please comment them down below. Please hit the like button, share this, and subscribe if you haven't. This should be a great stream tonight. This is the one that I was planning on doing last week, but I was sick, and so I was not able to do a live stream. I was very sick, actually. I could barely breathe. But I know it's a bit late tonight. I put my daughter to bed, and she's going through a developmental leap again, as I've said before. Anytime, for those of you who are not parents yet, hopefully, every time a kid goes through a developmental leap, they do not sleep very easily because they basically gain all these new powers to speak and to walk and to talk and to understand new things and to read, whatever it may be, and they're fascinated and entertained by their new powers, so they stay up and just entertain themselves. So and she made me read all of these books to her tonight. Let me just look at this, then we'll get started with the stream. All of these books, guys, every single one of them, from front to back, not exaggerating at all. Every single one of those books I had to read tonight. I'm not complaining. It's she's very cute, but it's a lot of reading. But this is something else I wanted to show here. This is okay. I got it, actually. All right, so let's get started. I will share more about just this journey that I've been on of observing this being go about understanding its world and grow. It's amazing. It's because you see, and it triggers so many memories from your past when you have a kid and you watch them go through things that you went through when you were 2 and 3 and 4, and you just don't remember because there's no context for you to bring it up usually. But when you start seeing your kid go through these same things, it triggers the memories to come back. Usually, if they're the earlier that the younger that your kid is, and the earlier the memories are for you, the more they are just like feelings. But as they get older, the memories that they trigger that come back are even clearer. And it's interesting because I'm having all these memories come back of me reading by myself at night after being told to go to sleep and stay in my room. And I just grabbed books and started reading. It's very interesting, but that's kind of what we're going to talk about tonight. We're going to talk about learning and the structure of mind and neural networks and observers, and basically the idea that the process of learning itself is the structure that the process of learning takes place within. That's what I'll say, which is the structure of mind, is the cause of the physics that we see. Okay? The universe is a mind. This is what Sentient Singularity Theory assumes, and it's not the only theory that assumes this, obviously. And it is thinking, and it's learning as it creates more within itself, and new circumstances and moments happen within it. It is learning, and so there is a structure and a specific process that is the process of learning. There aren't many ways of learning. There's one way of learning. There's different, approaches that people can take to learn. But as we spoke about last week with the talk about the shape of the Earth, which was really a talk about how should we process information that we take in. It's not really about the shape of the Earth. It's about it's about the process of thinking about something like that, and that idea is just used as an example. But there are different ways that people approach learning, but there's only one way to learn. There is one specific process of learning, and that specific process of learning is very intertwined with the process of thinking, which is also a very specific process, and they take place in the same structure. That's the structure of mind. And there is a neural network that is structure that is part of that. And you are not I don't want to say you are a neural net, but your mind, the structure of mind and you are a mind, but that means like part of your structure is a neural net, but you are not an LLM. I will say that. But you have the same exact structure in you that you use to process information, just like LLMs do. But we just outsource that processing when we use an LLM. It's not that it's even thinking; it's that we are thinking with this tool. But we've kind of outsourced that mechanism, that process, to, when we look at an LLM. But so these are all very relevant ideas to my work, but not only mine. A multitude of people at this point, and it is definitely a growing idea in physics, and I think it is absolutely correct. And Curt Jaimungal had, I hope I'm saying this correctly, Vitaly Vanchurin on, who is a professor of, I believe, physics. Let's just look at his intro here, or his background, just so that Vitaly Vanchurin, he's Russian, he's married. I always, we speak about marriage a lot on this channel. Very important. Helps you be a better thinker. And it says what he's interested in here, but I'm looking for his professor at the National Institutes of Health, CEO and co-founder of Artificial Neural Computing, cosmology, relativity, neural networks. So physics and neural networks, basically, it seems. I'm looking for, specific accreditations, but that's it. It doesn't really matter. You can look into it, but very, very relevant things to what we talk about on here. It was a great discussion that they had. It's one of my favorite episodes of Theories of Everything of Curt Jaimungal's channel, and it is linked below, their full talk. I definitely recommend it. I'm going to try and keep this one short. Help me in the comments, in the live chat, because I can go on and on, but I'm going to try and end this before midnight Central Time, which is in about 2 hours, less than 2 hours, almost 2.5 hours at this point, or 1.5 hours at this point. So let's look at the intro. Here we go. First clip.
It likes to be observed, and so observe it.
Okay. Hold on.
The universe is self-tuning itself. It likes to be observed. And so observers emerge not because there's carefully chosen constants of nature, but because if they were not carefully chosen, then they would be learned to evolve towards being carefully chosen.
5 years ago, an unintuitive and startling result was dropped like a bombshell. Professor Vitaly Vanchurin of cosmology found a way to model the universe as a neural network where the learning dynamics are the physics. This has huge implications for what the cosmos is, what you are, and potentially what consciousness is, and its relationship to everything. As you'll see in this conversation, this is not another way of saying that you can use neural networks to simulate general relativity or the standard model. That's been done. Instead, the professor shows that the universe's own learning is the physics. What happens is gravity falls out, the Dirac equation falls out, Klein-Gordon falls out. The algorithm behind most modern AI, copacetically named the atom optimizer, implicitly carries a curved metric on parameter space.
The presence of the
Okay, so if you've been following this channel and this project, this should sound actually like very familiar to you. But I'm going to play an audio clip in a minute, just to show how aligned this is with my own metaphysics work, philosophical metaphysics work. This audio clip that I'm going to show was taken during a discussion in 2021 with people who have a bunch of PhD students in physics and math. And I am only going to play my audio in it because the conversation was being streamed at the time and they knew that, but they asked me not to play, to take it down and to not play it because they got angry with me. Is that because I was saying something that offended them, which was just my theory, and the idea that I could have stumbled on this without trying to do it, basically. And as I've said on here before, I was working on originally trying to deduce the inevitable goals of an eventual AGI and how it would be politically relevant to humanity. That's what I was trying to do. It was just a personal question. I was wondering if it was going to doom us even more and make politics worse, or if it was going to be the only thing that saved us from our own toxic politics and increasingly powerful technology. But I realized I had to understand the structure of mind, and so I started really just examining my own thinking process. That's what I was doing. I was using my own mind as I was thinking about this as a model for, as an example of thinking that I could kind of get an inside view of, a firsthand view of. And I ended up basically creating a bunch of models. Some of them ended up looking exactly like neural nets. And so eventually I ended up realizing that the symmetry structures that I had been seeing in my thinking models, in my models of mind, basically, were the same symmetry structures that exist in many physics models. The first one especially that I had realized was the standard model. And that is basically how this project started. And I was like, wow, that's very interesting. Let me dig into this more and actually start learning a lot more about physics. And the more I learned, the more confident I got in this idea that we are inside a mind. We are minds inside of a mind. And that dynamic, the structure of mind, meaning our minds and the mind that we're within, and the dynamic between the two is what is responsible for our physics observations. And so this audio that I'm about to show is from a discussion where I was basically presenting this idea. This was way before the term sentient singularity theory existed. I didn't have my own theory. I just had models, and I was like, I think these are relevant to other people's work. These people found that very offensive. It's just because I was not a physicalist, basically. That's what it was. It's interesting because later on in this clip, in this discussion between Curt and Vitaly talks about how whenever he presents this idea to people, he examines how they react. I totally understand why that's the case after telling people this, explaining people's sentient singularity theory to people, because they don't react how you would expect them to, because it has profound implications that we're going to get into tonight. But this is my my audio from that discussion. When you stop laughing, I will explain to you exactly how I did it. I was trying to understand artificial intelligence. And if we're running on an artificial intelligence, then it would make sense that the laws of physics would mirror the laws of how a mind is structured for an artificial intelligence. I was trying to understand artificial intelligence and its political implications. I was working on AI, but I wasn't working on physics. But if physics and AI are the same structure, then yeah, that's how you do it. It makes perfect sense. It's not, oh, I'm just so arrogant. I'm not arrogant. I'm confident. When you stop laughing... Okay. As you might have heard, they were laughing at me, which is fine. I understand. I came into this with no background in it, and I get it. I'm not self-aware. I'm totally aware of why that would make people very suspicious of like whatever I could uncover. But the fact that they were very threatened by it is because, and specifically they had stated I was very good at articulating my ideas, and they thought that it was dangerous, actually. But to bring in a meme, that's not it. That's it. I've been saying it. Since 2021, I have been saying the same thing that basically it seems like Vitaly is also saying, and he's not the only one either. But what's very interesting about this idea, and specifically Curt called it out, is that it's not just another like example of somebody using AI, or I hate the term AI, as many of you know, I call them dynamic network algorithms because that's what they are. And they're basically the next level up of a calculator. And that sounds like I'm belittling it, but I'm not. But that is what it is. All of a sudden it's like not even a self-updating. It's a cooperatively updated calculator that stores information and builds on it. So it gets better at calculating, but it's just calculating. And that's, again, not to belittle it, but there is a process of processing information and that is specific. And we do that in our minds, just like a neural network does. We have a neural network that is part of the structure of our minds. And that but when a lot of people have been using it or trying to use AI or LLMs, ChatGPT, Grok, to model the universe and to model the laws of physics, and also to try and come up with new theories of physics. And I don't think that is going to work. But that doesn't mean they're not helpful for you working on new theory, but it doesn't come. I believe you need imagination, and in order to really think, and it doesn't have imagination. We provide the imagination in the prompt that we put in, and in the information that it's pulling from on the internet. And so, but my point is that people are using LLMs and AI to try and come up with new theories and to try and model the universe. That's not what Vitaly is saying is happening, and that's not what I'm saying either. In that clip that I played of Vitaly, and in the clip that I played, the audio clip of me, what I'm saying is that we are now within a huge tech revolution. Yes, we are. What I'm saying is that, and I'll get back to the chat in a minute, that the laws of physics that we observe are actually the structure of mind that they're due to the structure of our mind and the structure of mind that is the universal mind itself, the universe itself, and us being within it, and us having a relationship between the two of us. What we do and what they do, and it is a someone. That's the thing about sentient singularity theory. It's not it's that it proposes that existence itself is a singular sentient being, a sentient singularity. You are also a sentient singularity. You are a sentient singularity inside of a sentient singularity, which is a sentient being inside of a sentient being, which is a mind inside of a mind. And what that being does impacts what we do, and what we do impacts that being. And so this dynamic is responsible for, or this context that I just described, the structure of our mind, the structure of its mind, and the relationship between the two of us is responsible for the physics that we see. It is the physics that we see. It's not that you can model the universe using a neural net. It's that the universe has, as part of its structure, its metaphysical structure, a neural net, basically. And which is just the structure of mind. I don't really like the term neural net, but I'm going to show more about it in a minute. And so that's what I'm saying. And I have been saying it for since 2021 to other people, but I had this idea since like 2016. I started thinking about this, but like 2017, 2018, I had like figured out that I had stumbled upon something that there was a lot of evidence for. The more that I looked, the more evidence I found. And so this is not actually a new idea. And they talk about this even in the interview with Curt and Vitaly, is that, somebody kind of mentions that somebody in the comments will say, oh, that this was actually said by some philosopher from the 9th century or whatever. I'll play their actual clip in a bit. I know I botched that, but and that's true. But I mean, theism is this idea. Theism is this idea. This is theism. It's not any specific theological tradition necessarily, but it is theism. It is the idea that theism is the idea that existence itself is someone. Someone. And that it is that someone has created everyone else that exists within itself. And that is theism. That it's distilled, like, most simplified definition, which is what the definition that we should actually be using. There's different theological traditions, a bunch of them: Christianity, Judaism, Islam, like maybe you could argue Buddhism and Hinduism as well. But I think you can. But Sikhism for sure. These are all theological traditions. So there's many people the majority of people in the world believe in theism. This is theism. This is just the physics context of theism. That's what it is. And so that's not, in many times when people say, oh, somebody else thought of this earlier, and I even said that I presented a clip of me saying this in 2021 to people. And it wasn't when I first came up with it. It was after I had come up with this and had this idea for a few years. But people thought of it way before me. But Abraham, maybe we can credit with like the first person to come up with the idea of theism. But can you even do that? I don't know. Maybe they, actually, even if you believe the stories of the Bible, then the people who existed prior to him, knew of God. So, what I'm saying is that's a profound thing that we are coming back to this. There's a book called The Return of the God Hypothesis. That is, I forgot the guy's name who wrote it. He's a philosophy professor, and he specializes in philosophy of science. And he's a Christian, and he wrote this book, Return of the God Hypothesis, and he's a very big proponent of like the fine-tuning hypothesis and stuff like that, which I actually don't think is correct. I think that God doesn't really have that the constants of nature and the laws of physics that we see are emergent due to the constraints that of God himself, not actually like due to him picking like and tuning everything. I don't think that makes sense. According to my models, a lot of things just fall out. Like Curt said, gravity falls out. You know, I saw that the standard model fell out of my work. The symmetry structures in it. I'm not a mathematician, but the symmetry structures in it. The idea that there is a speed of causality, which is really what people say the speed of light. Really, what it is it's the speed of causality. It's the fastest that anything can happen relative to anything else, kind of like, and that idea does fall out of sentient singularity theory's models as well. So these things wouldn't be falling out of this stuff. I think if the fine-tuning hypothesis was correct. I don't believe in that, but I love the name of his book, Return of the God Hypothesis, and that's what this is. This is the actual return of the God hypothesis, and if that's why, as Vitaly had said, is that the universe is learning, and it likes to be observed. And it's like it has desire, it has will. Okay, it's things alone do not have will. Beings have will. Something does not have will. Someone has will. Okay, and so been saying it, but I'm not the only one, and that's a good thing. It's not to belittle it. That's profound. That's truly profound. Okay, let's go to the chat. I do wonder, faking it, when it comes to our true crime community. I don't know what that means. Our imagination is what points us in a direction. What questions to ask next? Exactly. Our imagination is part of our thinking process. And that's why without anyone to prompt anything into a neural net or into an LLM or a DNA, into a dynamic network algorithm, these AI systems, they don't move. They're not animated by themselves on their own. They are animated by us and our interaction with them, and also by our interaction with each other as we go about, everything that we do on the internet, that, producing information that feeds into the system. So it's not an animated being. Beings have will. They have imagination. Even the simplest beings, and the lowest level of beings have imagination. And sentient singularity theory proposes that the first level of beings, of minds within, or of life, you could even say, if life means anything actually relevant, you don't, to understand what life is, you look at what makes you think about yourself first. You're like, I'm alive. I know that more than I know anything else is alive. I know that I'm alive. What does that mean? What does it mean for me to be alive? And what would it mean for me to not be alive? And basically you eventually arrive at, I feel, therefore I am. Not I think, therefore I am. I feel, therefore I am. Also, I think, therefore I am. But as we talked about before, thinking is an action. It's a metaphysical action. Feeling is a passive thing. It is not an active process necessarily. It's a perceptive. It's the process of perception. It's not the process of action. Whereas thinking is a process of action. Actually, it's not just the process of perception. You can think. Only sentient beings can think. Only sentient beings can think. But sentient beings do feel. They have no choice. We always are feeling something. We always have some type of emotion. Every time you see something, this light is you feeling. That's the same thing. You touch something, you hear something, you smell something. You also have an emotional response to it. That's also a feeling. You can't stop feeling, but you can stop thinking. I do it every night at the end of the day when I try to, when I turn on the TV and watch too many episodes of a show that I'm binging on Netflix with my wife. And by the way, just watched Prime Target. Very good. I was planning on talking about it at some point. It's about a mathematician who has a prime number theory, and it's relevant to cryptography, and like the NSA has like a conspiracy against mathematicians working on this. It's very interesting. We'll talk about it later, not even for the math, but it's just interesting because it particularly in regards to its just how it presents our institutions. And if you've been following the news, there's a lot of relevant stories coming out about intelligence agencies and their relationship with universities and also scientists and corporate entities as well. It's real life is just as interesting as anything on the show. So, all right. But imagination is necessary to thinking, and the reason why is because of this. It is because the way in which you think. I'm going to show a model here. This is the very first model of sentient singularity theory that I ever made, and it's a model of a neural network, basically. And okay. Okay, no, actually, here it is. I just opened up one that's not. Okay. Where is it? Let's go to sentientsingularity.com. Sentientsingularity.com. Here we go. If you go to models, some of these models are much more refined. Some of them are just me messing around. But there is this right here. So this is the first model I ever made, way before it was called Sentient Singularity Theory. And it's just about the process of thinking. And first, you have will at the top, desire to do. The desire to, basically, it's kind of like the desire to do that which is not being done, which is kind of requires imagination, okay? And because you need to think about what's not being done. You need to be able to look at a mountain and be like, I need to go up that mountain. What would it be like to be up on that mountain? Like, and think about it first, and then it just motivates you to do it. You don't just look at mountain and just go up. You think about, I kind of want to know what is on top of the mountain. Even that idea requires thinking, requires an imagination. And so if you've never been on top of the mountain, you have to be able to imagine that you could be on top of the mountain. And so then when you think about something, let's say we'll use the flat earth hypothesis again, because it's just a great one to use. Let's say you think the earth is a sphere and you want to actually be and honestly consider the idea that it is flat. I don't think that the shape of the earth is really relevant to fundamental physics at all. But regardless, I mean, well, that's for another stream. But you have to, again, if you believe that the earth is a sphere and you want to honestly consider the idea that it is, and give thought to the idea that it is flat, you have to assume that it is flat and then look for evidence of it. So basically that also requires imagination. You have to reject your current default status. So if you currently think that it's flat, you want to honestly consider the idea, think about the idea that it is a sphere, and look for evidence of that. You have to assume it's a sphere and then look for evidence of that. We confuse ourselves and we screw ourselves up, and we think that we feel like we've thought about something. See, that language is very important. To say we think we've thought about something is wrong. We feel like we've thought about something because what we, in many instances, and we haven't. What we do is we say, people, you'll believe the Earth is a sphere, and somebody will say, no, like actually, like maybe it's flat. Like what about this? What about this? What about this? And you will not actually look at anything that they're saying. You will look at evidence that it's a sphere. But the thing is that you already know that evidence. Otherwise, you wouldn't have the idea that you currently hold. And it's also not. It doesn't give you the opportunity to update your assumption, because you're only looking for evidence of that which you already assume. And so you're either going to find more evidence that convinces you that it is what you currently assume, or you won't find any more evidence than you already have, you still won't change your mind because you didn't look for evidence of the opposite of your default assumption. So there's no opportunity for you to update your default state. And so you can't actually think when you're looking for evidence of what you already assume, at least at first. Like if you want to actually challenge, like think about something, you have to start by with this process. So you don't have to constantly do this. You can't. You won't. That's also not thinking. You can't just constantly. When people say the only thing that I know is that I don't know anything, that is a self-defeating statement. It doesn't make any logical sense whatsoever, and it doesn't jive with you even being alive right now. So it's just a nonsense statement. It's like fake humility, but that's true. It's just a trained statement. You have to assume. You have to have assumptions, like we do, and so this is, I think, something that like scientists today, in academia especially, get wrong when they speak to the public, and they will say things. And Neil deGrasse Tyson does this all the time. He's like, I don't believe in anything. I look for evidence. It's like, no, you can't actually think about anything if you don't actually also already have a belief about it and admit your belief, and then also look for evidence of the opposite of your belief. Like that's how you begin thinking about something. Even Vitaly makes this mistake here, but I don't think he obviously does think about these things, but I think that it's a mistake to speak about it the way that he does in this next clip that I'm going to show right now. Okay, so.
Theories of everything. Professor, you claim the universe is literally a neural net, so not that it's a useful model, it literally is, ontologically. Justify yourself, young man.
Okay, not so young anymore, but I'll try to do my best. Now, when you're saying that I claim the universe is a neural network and not just a model, if I did say that at some point, I want to take this back, okay? As a physicist, I am not, as a theoretical physicist or as a physicist, I'm not allowed to say what the universe actually is. What I'm allowed to say is what is a good way to model it. Because at the end of the day, I cannot really know or check or test, prove or disprove whether this is how the universe works. But I can test and check whether any given model, mathematical model, is good for modeling, some types of phenomena. So if I did say that at some point or somebody misinterpreted, no, I'm always talking about what's the good model of describing it. And at that point, I have to say it looks like it's a promising candidate. It's not a final. There's no final verdict yet, but it's a promising candidate that should be explored. Whether it is a good way, convenient way, compact way of describing phenomena in the universe using neural networks. In perhaps how exactly I want to do it. we can discuss later. But I just want to open all my cards and say I would never claim that this is how the universe works. Now, if we get to philosophical questions, of course we can say, what if, right? What does it mean? If this is really the universe, how the universe is, what kind of philosophical conclusion we can reach out of that? But as a physicist with my physicist hat on, I can only say this is a interesting, good model, and it works remarkably well in the places where I wouldn't expect it to work well.
Okay, now people who know some things about neural nets know that they're universal function approximators. So why would it be surprising that neural nets can satisfy functions, which the universe, this would be more surprising if you had the counterclaim. The universe cannot be modeled by a neural net.
I think this is an excellent question, okay? And it actually, now I can actually put my finger on exactly what I mean, right? It is true, right? Why should we be surprised, neural networks are universal approximators. Why should we be surprised that you can use neural networks, well-trained neural networks to, reproduce the dynamics that we observe in classical.
Okay, I want to talk about that next statement that Curt, the question that Curt asks, because it's great in a minute too. But if you heard what Vitaly said in the beginning, he's like, I can't, as a physicist, like claim that this is what the universe, how it actually is. But with my physicist hat on, this is like a way of modeling it, and I understand what he's getting at and why he's saying that. But I also think that you cannot separate philosophy and from science. It's not really possible. If you're an experimentalist, but when people are like, Brian Keating says this all the time. He's like, I'm just an experimentalist. I'm not a theorist. The reality is that an experimentalist is just an engineer. Like when you say I'm an experimentalist, you're saying I'm an engineer. I can help engineer an experiment to test something. That is some idea that was, is being proposed by a physics theorist, which is really a philosopher. That's what a physics theorist is. You cannot be a theoretical physicist without being a philosopher. It is the same thing. The only difference is the language that you use, and that's it, basically. There's no other difference between a philosopher and a theoretical physicist. And so this is a tough thing, because I think we have to recognize, especially if you're really focusing on the process of learning and mapping that, then what you have to realize is that that you are going through this process too. And what's interesting about the process of learning, this process that I showed here a minute ago, right here, is that this is just the internalization of the scientific method. It's you have a hypothesis that you present always, and then you kind of like look for evidence of it, and but really it's like you have to look for evidence of the opposite of the current default status. And this is usually what the scientific method is, because you are presenting a new hypothesis that is like some new idea. Nobody is just like, my hypothesis is exactly what we've all been saying for 100 years, and that's what we're going to do. No, the hypothesis is everybody says the Earth is flat. They have for thousands of years. My hypothesis is that is a sphere, and now I'm going to do an experiment to try and see what I'm gonna assume it's a sphere now, because that's the opposite of the default status, and we're gonna look for evidence that it's a sphere. We're not gonna continue to look for evidence that it's flat, and if I find that, then I'm not gonna think it's a sphere. That's not how this works. And also observation is part of this. So basically, this is just a tree. It's just a tree, like a decision tree. But a decision tree is a neural network, and that's basically what it is. And so a neural network diagram. Let's look. This is a neural network. What's interesting about it is that it's always got this. It a lot of times, at least, seems to have this triadic structure to it, that's just built in all the time. And when we say this is, computer science, this is a neural network. Okay. All right. Well, that's a neural network. Well, what's interesting is that in theology, in actual like the metaphysics of of ancient theological traditions, they came up with the same exact structure as the structure of the universe. And this is this. It's not the only. The chakras are probably this type of thing too. I don't know. Like, I don't know anything about chakras, to be honest. But like, I'm assuming that like this, it has some kind of relevance to this. But I know that this does the structure that I'm about to show you here, because this is like related to the theological tradition that I study, which is Judaism. I study all three Abrahamic traditions. I'm very interested in all three of them. I think they all contain a lot of truth, but that doesn't mean everybody's interpretation of things that are in these scriptures is true. But I think that there's a lot of truth there. And if the universe is a mind that is learning, if existence is a mind that is learning and likes to be observed, like genuinely, then theism is true. But so here is this. This is called the 10 Sephirot or Sphirot. This is considered the Godhead, they'll call it. It's a map of the mind of God, which really is a map of just mind itself. It's not. It's kind of like cosmos. It's just a map of the cosmos, but also a map of the mental processes of God, and what these various attributes are that are interconnected and have a hierarchy structure are things like will, the desire to do, like this at the very top, motivating all this process is this. And I came up with this on my own, by the way. I was not a theist at the time. It's this project made me a theist. I was an anti-theist, an atheist at the time. I deduced this and wrote it myself, and then was like, wow, this kind of would mean, if we're inside a mind and the universe is a mind, that kind of sounds like God. And then I looked more into things and look at that will at the very top of this triadic decision tree structure. This is will at the very top of this triadic decision tree structure. Not a coincidence. Not a coincidence that it looks like this. It's just because it is. Understanding, wisdom, love, beauty. This is about like recognition of certain just it's feelings, basically feelings. They're different feelings that are interacting with each other to create other feelings, like wisdom versus understanding. What is wisdom? You have to think about it. It has to do with personal experience. What is understanding? Understanding is related to wisdom, how, you understand, related to wisdom, basically, but it's like the mental processing side of a situation. So this is all just that. I'm not saying there aren't other things about it that but that are more, you could find in scripture and things like that. But this is metaphysics. And we've been shying away from the term metaphysics for a while. And what's funny is Stephen Wolfram was using the term metamathematics for a while. And that's because metaphysics but he's using his metamathematics to try and come up with a model of physics. It's because metaphysics was associated with like things that were assumed to be not true, which is the idea of God within academia. And now even Stephen Wolfram is using the term metaphysics again. And so it's the return of the God hypothesis, guys. It's happening. And whoa, sorry. There you go. I've been saying it. But apparently not just me. This looks a lot like my thinking structure. And it looks a lot like a neural net. And that's a fascinating thing. And you have to admit when you have to have a hypothesis. And so I don't think you can say, as a theoretical physicist, I cannot say what the universe is. And I understand that you cannot actually prove any like the fundamental, what is fundamentally true about existence to anyone else, but you are constantly, it is beyond proved to you. It's constantly confirmed. And this is what Stephen Wolfram even said. He's like, when we're talking about fundamental theories, what you can't look for falsifiability or proof, because what you're looking for is structures that are ever present, like the structure of mind. And so then you'll start looking at things like a standard model. Just to prove my point. And how you arrange the standard model will change how you view it. But if you arrange it like these, kind of, you can see that there's this triadic structure again in the standard model. And what's interesting is that even in the standard model, we call this like the bottom or beauty quark. B-E-A-B-E-A-U-T. I can't spell. Bottom or beauty quark. The top or truth quark. By the way, that's not my statement. That's not my terminology. That's the terminology of just physicists. I'm pulling it up. It's like charm, strange, top, bottom, or beauty. You can find it depending on the model that you look at. Some people say beauty, some people say bottom. Where is it? I'm trying to find an instance of it. People don't say beauty very much anymore, but it is it is very much was used more often. Now people say bottom. Let's see. Beauty. Where's the quarks? Bottom. Or beauty quark. There you go. The bottom or beauty quark. Or let's go to the top or truth. The top quark, sometimes referred to as the truth quark. Okay, so if you look at this 10-sphere model, you have it's similar language. That's what I will say. Rigor and grace, and which is kind of like the opposite. And just depending on which model you're looking at, which loving kindness, endurance, majesty. It's like beauty, harmony, beauty, truth, judgment, wisdom, understanding, will. This is what I mean by there is evidence that the symmetry structures that are found in this process right here, a neural network, which is the same thing as this, are also found in the standard model. And so that is evidence that the information that we are observing is being processed through the same structure that is an information processing structure that is the information processing structure of learning or thinking or mind. It is the same. And that's what I mean by I saw the same symmetry structures. I see the same symmetry structures that this is evidence of Vitaly's idea being correct. It is evidence also of theism. But it's also evidence that you can't separate our minds from the structure of mind from the laws of physics that we observe at all. You can't separate our minds from the laws of physics that we observe. So observers, people talk about observers all the time. Even Stephen Wolfram talks about observers, and like I've stated for a while that he says that there's atoms of space, and basically like what this will end up being, I think, is it is a moment or a circumstance that is defined by how by the perception of the beings that are involved in it, in this circumstance, that are perceiving an event in a specific event. That specific event is what Stephen Wolfram is looking for, these atoms of space, and I think that you could even say that these atoms of space are the observers themselves, because in Sentient Singularity Theory, it's the observers or the minds or the someones, the beings that come first, and then their interactions create the observation of things, because the observation of things is the observation of the laws of physics, no matter what it is, whether it's we're observing an electron, which I don't believe is a sentient being, or we are observing, I think a proton is a sentient being actually, but not an electron, but we'll come back to that. Or a glass of water, like even whatever it may be. Though that is, it's us as a mind being within a mind that is dictating whatever it is, the thing that we're perceiving. So beings do not emerge from things. Things emerge in the observations of beings. That's what Sentient Singularity Theory would propose. I don't know if Vitaly would agree with that, if he thinks that sentience is fundamental or not, I say sentience, not consciousness, because feeling is the definer of whether or not you are someone. And but there's so much that in linguistic structures and our mathematical structures. You look at our mathematics, our order of operations. Please excuse my dear Aunt Sally, parentheses, exponentiation, addition, subtraction, multiplication, division. This is a binary triadic structure as well. And it's because it is the structure of mind. There's people talk about there's 3 generations to the elementary particles in physics, or at least, of the fermions, but it's more than just that. But there's this is because of our information processing that's going on. We can only observe information in the manner in which, according to the symmetry structures in which our mind itself, because that is how the information is being organized. And so you see this everywhere. It's like parentheses, exponentiation, addition, subtraction, multiplication, division. Red, yellow, blue, green, purple, orange. The primary and secondary colors. Magenta and cyan and yellow. This is additive color mixing. And or red and blue and green, subtractive color mixing. One of them is how a printer can create every color just from 3, or how a screen creates every color just from 3. Your computer screen that you're watching me on right now actually only has 3 colors to its pixels. It's either red or green or blue. And your printer ink that you get, you don't have to buy turquoise. Let's not use turquoise because it's close to cyan, but you can't buy green. You don't buy green ink for your printer, but your printer prints green. You just buy cyan, yellow, and which is super kind of bright blue, and yellow and magenta, which is kind of like halfway between purple and pink. And from that, we create every color. It's like, why is this binary triality structure everywhere? And I have it here. So I've showed it. When I say it's everywhere, I mean it is legitimately everywhere. Right. Come on. Too many tabs open. And too many tabs on my symmetric set. Here it is. Okay. I need to make it every few years. I make a new document. I used to do it every year. Now I do it every few years. With my Excel models, I take the most up to date, like refined and confirmed Excel models, and I move them. But I haven't done that in a while. This right here, like everything here, your senses. You have 6 senses, by the way. One of them is emotion. That's your 6th sense. It's not like the ability to see ghosts, but it is a great movie. It's The Sixth Sense. Great movie. I won't spoil it. But definitely watch it if you haven't. It's not the ability to like see the future. It is emotion. It's the ability to feel yourself, your metaphysical self, your someoneness. That's what emotion is. It's this to feel your super self, not even just like, and how that's being impacted, not your physical self. But what's interesting is that there's always this binary triadic structure to it. It's like emotion and taste and touch are when things actually impact you. This is when things super, physically impact you, metaphysically impact you. This is when you have to touch your tongue to something to taste it. You have to touch something with your hands to touch it, But then when your sense of sight and smell and hearing, these are your senses that you use that are perceived by you to as the ability to observe things that are not connected to you or not touching you. So you see things that are over there, you smell things that are over there, you hear things that are over there. But when something touches you, you feel it emotionally. When something touches your tongue, you feel it, you taste it. And when something touches your skin, you feel it in your sense of touch there. Same thing with parentheses, exponentiation, addition, here. Same thing with your limbs, your arms and your hands and your fingers and your legs and your feet and your toes. And if you look at your finger, you will divide the different parts of your finger into 3 as well. If you look at your fingernail, you will divide this structure into 3 parts as well. You will do this again and again and again, and it will fractal, because it's coming from here and also from the mind that we're within. This binary triadic structure that we see even in neural networks all the time. 1, 2, 3. It's constant. 1, 2, 3. By the way, look at that versus that. It's the same thing. It's also the same thing as that. But it's also the same thing as this, which is the standard. The standard model, basically. And I have a few different things added here that I think are more accurate. But the graviton, when I say graviton, I mean the universe itself is the graviton. It's the force carrier particle of gravity. Gravity is the universe moving itself. That's what it is. And so very clearly when you think about it, it's not a tiny particle, the graviton. It's not so small you can't see it. It's because you're inside it. It's like you're looking for the forest through the trees. But this, you look at, even here, strong force electromagnetism, weak force. That is a triadic structure. Weak vector, particle. These are the 3 bosons that carry these forces. that they correspond with their colors here. Photon is the force carrier particle of electromagnetism. Gluon is the force carrier particle of the strong nuclear force. Weak or vector boson is the force carrier particle of the weak force, which is like nuclear decay, basically. And same thing here, though. You look at the electrons. You've got 3 generations: electron, muon, and tau. And you've got electron neutrinos, though, and muon neutrinos and tau neutrinos. So you have here, this is a binary triality, just like, where is it? Hold on. Oh my gosh. Trying not to show you my messy desktop. This is binary triality. So is this. So are the quarks. You've got up charm and chopper truth, and down strange and bottomer beauty. And between the forces and the force carrier particles, you have also a binary triality. 1, 2, 3, 1, 2, 3. Same thing. It's everywhere. Everywhere. Matter, gas, plasma, liquid, Bose-Einstein condensate, solid, like, and sentience. Nobody includes this one, actually, but this clearly exists, and people say it's not material, but it is like, when you sum all of this, it sums to this, ultimately. I'm not saying anytime you put a bunch of those, solids and liquids and gases together, it's a sentient being. This cup does not contain a sentient being, but its molecules probably are sentient, and the protons and neutrons within its atoms are probably sentient. Probably are beings. They are observers themselves. And we're going to get into Vitaly's statement on this, because it's very similar to what I've been saying as well, that about how the elements or the atoms go through the same evolutionary process that every cellular living being also goes through. That's why we have different elements, and they used to call them the different species of atoms. That's what they used to call them. They used to say the hydrogen species, the oxygen species, the gold species, and they are created when the conditions change within a star, usually, it's an evolutionary process. And Vitaly even brings this up as well. So but even that idea indicates that there are sentient beings or minds that are persist throughout the universe, and that are on specific levels, though, that are in specific instances. Not everything that we see is a sentient being, but ultimately all there really fundamentally are sentient beings. And this is what makes it hard to prove, impossible to prove or disprove anything in a fundamental theory. You seek constant confirmation. That's what Stephen Wolfram was saying, to bring it back to something that I was about to say a long time ago, and then I went on a tangent. You seek constant confirmation. You don't need how can anyone prove to you that your dog is a sentient being? They can't. But how can you prove to me that you're a sentient being? You can't, even though you know you're a sentient being. So what do you do in these circumstances? Why assume that your dog is someone that likes to be observed, or that is learning? You look for evidence of that, and that would constantly confirm that idea, it makes sense. But you'll never prove it, because you can't see the sentience of another, and they can't see it of you, though, either. And so even though you know beyond proof that you are someone, that you are sentient, and that you feel, you can never prove to me that you feel. I can look for evidence that you feel. I can poke you with a pen, and if you say ow, I'll be like, that's evidence. It seems like he feels, but I can't prove it. But I look for constant confirmation. And that's what you have to do. And so, but what we can know is I know that I'm sentient. And if you are someone, I don't even need you to be someone to prove it to me, but if you are someone, you know you're sentient. Everyone who is anyone knows that they are someone. And what that means is that anyone who is anyone who knows that the definition of existence from a first-hand perspective, that we know more truly than we know anything else, because we know we exist more truly than we know anything else exists. That means that we know, to the best of our ability to know, that existence itself has, as an attribute, sentience, and as a nature even, sentience. You have to assume it. Yeah, you can't see the sentience of the universe. You can't feel its feelings. But you feel your feelings, and you know you're sentient. And that is the truest thing that you know to exist, and that means and if you didn't exist, it would mean you don't feel anymore. That means that you must assume that is a definer of what it means to exist. People will be like, but I mean, there were rocks before there were people and cells. Yeah, but you don't know whether or not the molecules in those rocks are sentient. I'm not going to say the rocks are sentient because I don't believe that. But again, you can't prove that they are or that they're not. But it doesn't really make sense that they are. That's why most people's kind of less rigorous, less defined conceptual models of panpsychism don't usually end up catching kind of scientific support, because they're not defined clearly enough. And there's also like, if you're like everything is conscious to some degree, and you're like, this pen really doesn't seem conscious. But if you look at an atom close enough, it does. And its structures, its symmetry structures will mirror ours. A proton and a neutron are basically probably a male and female atom, or on the atomic scale. They are male and female beings on the atomic scale. They're like the first instantiation of like gendered beings in the universe. And according to my model, that's what is being proposed. And it's a philosophical model, so I can propose it. But you can't be proposing a theoretical physics model either without it being the same exact thing as a philosophical model. So you have to make an assumption. You have to propose something. And Vitaly should just... We need to find a way to just admit that we have to do this, that philosophy and theoretical physics are the same thing. It's just theoretical physics is philosophizing in the context of our physical observations. That's it. So you have to assume something. But remember, all the things that we see in our physically about our world. When I look at my limbs and I'm like, I have arms and legs, and then hands and feet, and then fingers and toes, and then fingernails and toenails. It's like, there's a structure here that's we see in the symmetry structure that we see in our limbs and our senses that we also see in the standard model. And that's interesting. And it also seems to exist in our internal feelings and our observations of color and our elements of design. These are the elements of design: texture and color, space or value and line, form, shape. This is very relevant to physics, guys. It's not separate. You just see it everywhere. This is how we observe the physical world. This one, at least, not this one. It's how we process part of it. But look at this. Space-time It's not length. It's not just length with height time. It's length with height. And then we look at time. We say, what do we see when we look at time? We see how do we process it mentally? The past, the present, and the future. That's how we process time. How do we process space? Length, width, and height. Or that's how we process space when we're looking at a thing in space. How high is that cup? How wide, the length, width, and height of that dresser, or that door. But we also can think about ourselves in a space, and we can say, on it, where are we in relation to the edges of this space? And we say X, Y, Z. So X, Y, Z, and length and past, present, future, or length with height and past, present, future. Same exact thing. And father, mother, child, grandfather, grandmother, grandchild. Anything after that is great grandmother, great grandfather. It's like there's no difference. It's just like an added level at that point. This is all evidence that we are in a mind, and that Vitaly's right, and that our physics, and not just our physics, but every observation that we have, and every conception that we have, is taking place in the context of mind, which is obviously true. That we know we know that individually. I call this like a super subjective truth. We have like objective truth and subjective truth. It's like, or an objective observation and subjective observation. There's no real such thing as an objective position or an objective perception or observation ever. There is a subjective observation. And you can look at the world from your subjective perspective or conceive of being within a system, and you can say that's subjective. Or you can think about it yourself as being from a God's eye view. You can think about, it's like looking at playing a video game first person where you just see your hands, like a first person shooter game, you just see the hands, and versus you playing from the perspective of behind the character and you're watching the character move, like the whole body of the character. You can think about these things, and you could say there's an objective perspective, but that's actually, it's still being processed by you. It's subjective. Like there's still someone observing, like it's just from an inside or an outside view. That's really what it is. It's not a objective and subjective. And, which I guess like it just depends on how you want to use the words, but still, I hope you get what I mean. And, but something that is super subjective, and this is my term that I want to introduce, is something that that everyone knows is true to everyone subjectively. It's like sentience exists. I can't prove it to you, but I don't have to. You know it based on you. I can't prove to you that I'm sentient, and you can't. But you can't. You cannot find evidence that sentience doesn't exist in the universe ever, anywhere that you look. It's always present. So with these things, you can't prove or disprove them ever. It's like you can't prove or disprove that mind is that we're inside a mind, because like we are a mind. You could say we're inside our own mind, but then are we inside also a universal mind? We can look for evidence of it. We cannot know. Like prove it. Like we can know it, but like we can't prove it to someone else. You can personally know it, but or kind of assume it, but you can't personally know anything more than truly than you know that you exist. And so like go and try and prove scientifically that the structure of mind even exists, which when we say prove scientifically, we're talking about a collective endeavor, which means like I have to try and prove to you that or you have to try and prove to me, or we have to try and prove to each other that mind exists. It's like, what are we doing even trying to do this? We have an issue where we have a missing term that we need that would just be associated with things that we all personally know are true, but cannot prove to each other, basically. Or at least it would at least encompass everything that everyone who is anyone personally knows. And that's a super subjective truth. It's that which is personally known to be true to me by me, but is also personally known to be true by everyone else, but can never be objectively proven to anyone else. You can't not have this with and you need this. I will say you need this idea, this a concept of like a super subjective truth. It's that truth which is known personally to everyone and universally, personally to you and also universally to everyone. That's what it is. It's personally universal. That's a super subjective truth. And you can't have a complete metaphysics and therefore a complete physics, and therefore a complete scientific like model of the universe without this concept included. And so that is a contribution within sentient singularity theory, is the idea of a super subjective truth, or a super subjective perspective, that which is observed or perceived by you personally, but also by everyone else. But good luck proving that to anybody, but you don't have to. No one will disagree with you who's sane. You know, it's just not. The next stream is going to be on probably this conversation that I'm going to listen to this week. I haven't listened to it yet, of Sam Harris and oh man, what's his name? We just did streams about him. He's a philosophy. I want to say kid, but he's not a kid. He's like probably older than me. And I just gotta see it now. It's gosh, I can't believe it. Alex O'Connor and Sam Harris, and it's called like consciousness without or spirituality without God or something, or consciousness. It's about consciousness without God. And you can't have the idea that it's all consciousness without existence itself being a consciousness, which means it's someone. And like that is the definition of God. But that is not something that is provable by anyone ever, other than maybe God. What you can do is get as close as you can to proving it. I guess he can prove it to people but like not to in as best as like as much as like your wife can prove to you that she exists. She can be like, I'm with you every day, but you can't actually know that she's real, or that there's actually someone there. It could be like a robot. I don't know. I don't think that's that, but you shouldn't assume that it is just because you can't prove that it is. That's my point. You have to look for constant confirmation of something that seems to be super subjectively true. And it has to be incorporated into your model. Okay, so with that aside, oh man, what time is it? I'm really moving slow. Let's go to the chat. I love that you share yourself so much with us. Thank you for telling me that. I try to. I think it's important. I do. I think that I don't want to come off as something. I'm not something. I'm someone. And I'm presenting what I think is true. And I think that especially with things involving sentience and mind and learning and observing and things like that, if you're going to present ideas about it, you have to present ideas about it from the perspective of presenting of you being someone presenting ideas about someoneness. That's what it is that I'm presenting. The sentient singularity theory is primarily a theory of everyone, meaning it is about the structure of everyone's mind and our individual perceptions that are true to all of us, which is it starts with the 4 primary perspectives of inside, outside, separate, and oneness. That is how we simultaneously observe all 4 of them anytime we simultaneously conceive of all 4 of them anytime we perceive any one of them. So if you think about like yourself inside a room, you say, I'm inside the room. That means that you also understand what it would mean to be outside the room, and you also understand what it means to be the room versus you, which are 2 separate beings. But you also understand what is one with the room, and what structures are one with the room, and what structures are one with you. And so like you simultaneously conceive of all of these things in order to orient within any kind of environment. But within multiplicity, that's how you orient everyone, from us to God, and inside, outside, separate, and oneness. And I assume this to be true. I can't prove it, but you can't disprove it because I bet you that because your evidence of my hypothesis or my model being true. So, good luck trying to falsify it. I invite you to try, but you cannot, because you cannot. You are evidence of it. If I say, are you inside the house or outside the house? And you're like, I'm inside the house. And I'm like, how do you know? Because I know what it would be like to be outside that. Okay. So you know what it's like to be the house and versus like to be you. And as well. Yes. Okay. Good luck falsifying these 4 primary perspectives. You can't. And that's not evidence that it's not meant to be incorporated into our scientific theories and models. It's evidence that we've hit a super subjective truth, meaning which is something that is true, that is observed everywhere that we look. And that is not evidence that it's not meant to be taken seriously because it's not falsifiable. It's evidence that you've hit fundamentality, and truly hit fundamentality, because you actually truly, every single one of us truly observes a certain structure everywhere that we look. All of us. And all of us know it. So that doesn't mean, well, then that's not part of science. Falsifiability is part of science. Science, insofar as it is defined now, and even always, science includes philosophical understanding and imagination of that which is beyond. You can't your current ability to prove, I guess. So the idea that we can't incorporate anything if it's not falsifiable is probably one of the worst things that ever happened to our scientific endeavor. Science as a method, yeah, it's just a method of experimentation, sure, but science is more than just a method of experimentation. Science is a collective endeavor that includes the method, a certain method of experimentation. But that's not the totality of it. And we know this. Otherwise, don't tell me about the many worlds idea, or even about the graviton. You have no proof of the graviton. None. Absolutely none. But it is assumed in our physics models to exist because of mathematical symmetries that are expected, and it probably does exist, but probably not in the way that people think. And but you have to, but you'll probably never find it because you're in it. But it's does that mean it doesn't exist? Does the ocean not exist? Does the Pacific Ocean not exist just because you can never see the Pacific Ocean? If you're on Earth, at least. No, It's just you can't perceive a holistic viewpoint of a structure or process that you are within, and you also can't perceive anything beyond it either. Okay. I think that it's some coincidence that 3 Atlas had the water burst sublimation such as Mexico same night. I don't know what that it was about, actually. I'll probably look it up after, though. Education also plays a part in our scientific thought. It totally does, and it really screws us up, actually, now. Like, but our language plays an enormous part in that, in our ability to conceive of things. Like, that's why I think it's so important to introduce certain terms like super subjective. And you will have, what's his name? People like Dave Farina, Professor Dave Explains, will be like, I know we're going to go past midnight. We probably already have. Gosh. No, we haven't yet. He'll be like, you just invented the name, this new word, super subjective. That's just an invented word. It's you made it up. It's like, where do you think words come from? Like, where did the word subjective come from? Did somebody not make it, like, construct the word subjective? Yeah, they did. They constructed it. It's not made up out of nowhere. Neither is the term super subjective. It's that which is subjective, yet also beyond. It's that which is universally subjective. Subjective and universal. Yes. Or individual and universal. That's what it is. It's that which is individual and universal. So your terms influence how you think. I told the story, like, I started telling my daughter, another side tangent, I started telling my daughter stories at night because I'm trying to get her to stop, like, making me read 30 books every single night. And it was working. And she's now, like, onto the fact that my stories aren't great because I make them up literally as I go. I need to start coming up with some stories before. And because I think I'm boring her, she's like realizing there's no narrative to these stories, or it's the same narrative every single time. And it only took a week for her to, like, lose interest in my stories. She'll be like, I want a story about an octopus. She's, like, obsessed with octopuses lately. She loves lions, and she loves octopus as well. Octopi. I think octopi and octopuses are both supposedly correct. But and so I started telling her stories about octopuses, and I'm like, mama octopus and a dad octopus and a baby octopus lived in the ocean, like, ridiculous. They turned red and yellow and green. There's, like, no real narrative. And at first she was, like, gazing into, I realized when I first started telling her stories, she was gazing into, like, she was just, like, looking up, and her eyes were so wide because she was imagining these images that she couldn't have imagined prior because she didn't have the terminology to do it. She now knows what an octopus is. But she never knew what an octopus was before. If I was like, do you know that there's an octopus and it turns red and green and blue? And she didn't know what red was, green was, blue was, or what an octopus was. Like, she would not be able to conceive of anything in her mind. It wouldn't be information to her. But now that she has context for these terms, she can see the story that I'm telling her. And it was like the first few times she was, like, amazed by it. It was like watching a movie in a movie theater for her for the first time. That's how her eyes looked. And she was just sitting in bed, and I was just telling her a story about, like, 2 lions on a rock or something. And so you cannot even conceive of things without having a term that is also built on other terms. So it has to be, you can't just make up you can't call, like, oobleck, like, that's, I think oobleck is like that, like, stuff that the slime that you make out of, like, cornstarch as a kid in science class or whatever. I think people call it oobleck, but you can't like let's say that word didn't exist for that, and you were just like, I need a term for that which is universally and also individually and personally perceived by everyone. Oobleck. That doesn't make sense because it needs to be built on other terms to continue having to have meaning. So super subjective, that's what it means. And it's not a made up term. It's a constructed term that we need. Okay. So this clip that Curt was kind of getting at, that I was going to talk about. Where is it?
The phenomena, but there are other well-known algorithms that anybody working in machine learning know about and use them daily.
Okay, hold on. Where is it? Okay.
Miscellaneous lay people. It's quite interesting because it's one lump here that's quite hardcore, and then another lump on the soft core. Let's call it.
I don't know where
It
that
must be there. It must be part of me telling you why harmonic oscillator can be described by neural network. So if we remove learning, it's an almost trivial state.
I think here it is.
This is head on. I can only say this is
It's
an
an interesting, good model, and it works remarkably well in the places where I wouldn't expect it to work well.
Okay, now people who know some things about neural nets know that they're universal function approximators. So why would it be surprising that neural nets can satisfy functions, which the universe is described by functions? Like, it would be more surprising if you had the counterclaim: the universe can be modeled by a neural net.
I think this is an excellent question, okay? And
This is an excellent question, actually. And I talk about this as well when Stephen Wolf, especially with like Stephen Wolfram and Max Tegmark. Max Tegmark has like the mathematical universe hypothesis. It's like, what does that even mean? Are you saying that the universe has like mathematics, runs according to mathematics? Like, what even is mathematics? We have to like get down to actually what we mean. Not to be Jordan Peterson, but like, what do you mean by mathematics? You actually have to like make sure that you know that. And when Stephen Wolfram, he'll say, the universe is computational. That's what I'm realizing. And my models are now, my hypergraph models are showing that the universe is computational. What the heck does that even mean? Computation is just kind of like a way of modeling causality on a smaller scale. Like it's just like, it's the act of modeling causality in a circumstance in a separate, smaller circumstance. Like, that's really all it is. You switch a 0 to a 1, and that switches another, a bit and another bit and another bit. And like this, it's just a causal, basically to say the universe is computational is just to say causality exists. Well, yes. Do we really need to like say that the universe is causal? That's what I've discovered. And that's a neural net is the same thing as like a computer, basically. In some ways, it's a universal function approximator. That's basically what a computer is too, and that's why a neural net is a process running on computers. And when Curt says wouldn't it be? Why is it surprising that like we observe that in the world? Then, and it's a great question. It's like, why would we observe binary logic in our world? Like darker and lighter, and bigger and smaller, and faster and slower. We're observing binary logic in physics. That's what that is. Heavier and lighter in mass, brighter and dimmer in light, faster and slower in speed. Like this is above and below, even like in spatial orientation. This is binary logic everywhere. And people, if somebody was like, yeah, well, that's evidence that we're running on a computer, actually. And it's not, but it's like, it's just that there's, it kind of spits out naturally from just the idea that there's causality. This, therefore that. Cause and effect. Cause and effect. Cause and effect are binary logic. It's like that's what binary logic is cause and effect. It's the best way to put it. I've been trying to figure out a way to like word it better, but it's like there's cause and effect are observable everywhere by everyone. It's a super subjectively understood concept or mechanism that exists in existence by everyone. Cause and effect. That's binary logic. That's computation, basically. But like, it's just that there's causality in a computer too that's being used. But binary logic is the fact that everything does appear to be binary. I don't know if that's evidence necessarily that we're inside a mind, but because it's just evidence that we are a mind. But like, do you need evidence of that? It's more just like you are able to perceive when you think about that what it means to what is required of thinking. That's what like what symmetry structures are required of thinking, and one of them is binary. That's why this binary triadic model that I was showing earlier is so important, and it's found everywhere, including in the standard models. Like, why is it there are electrons and neutrinos? Why is there up masculine quarks and feminine quarks? I call them that, but it's like there's up quarks and down quarks and top quarks and bottom quarks and beauty quarks and or truth quarks and beauty quarks. This is a binary aspect of this, but there's also this triadic aspect. It's your mind is processing information, and that includes differentiation, binary logic, this and that, this and not that. This is this and not this. Cause and effect. This is binary logic. It's different. It's due to the requirement of differentiation. And so your mind is split into this symmetry structure model, which so are neural networks. And it's about how information is understood is how it relates to how it is processed and kind of like conceived of in your mind in relationship to each other. So, and that's a symmetry structure. So you're like, cause and effect are two sides of one coin. And there's, I don't know, like subjective and primary and secondary colors, whatever it might be. But then there's also this triadic aspect to it, which is found in the generationality of quarks and the generationality of electrons. But it's also found in the generationality of people, and when we look at people, and so that's due to things like it seems like which is the requirement of it for information to be organized into a hierarchy, like in a hierarchy of causation, like but also a hierarchy of value depending on in relationship to a goal that we have, which is will, and then also categorization, which is why it's like when you say A and B, there's option A and option B, and it's like, no, there's also the option of it being both. It's like A, B, C, D, all of the above. It's like really you could do A or B or both. You could also do or neither. But like, if we're assuming that it's something that there is a way of categorizing, then you can't pick neither. But the fact that neither is a way that we can kind of objectively, to use that word, understand that there's something beyond like with being our perception within the system, which is like length, width, height, and time. It's like time is not perceived by us in a physical sense. In space, it's not. But what is time? It's just the observation of spatial change in a causative chain. Basically, you're just observing causation. So like all of this is just interlinked, And there's this binary triadic structure that your mind splits information into, and it's found in neural nets, and it's found in computing, and it's found in quantum computing, and it's found in multiple choice questions on tests, and it's found in the colors that you see. It's found everywhere. And the question is then, is this evidence that we're inside of a mind? It's evidence that mind exists, and at least, and we, and there's no way for you to escape it. So there's other like arguments for why we'd be inside a mind, but the fact that it seems to be something that that is the truest thing that we can know about existence is that it is at least sentient. There's a lot of implications to that, but I can't get too into it. I'm trying to think of a way to condense it because I know I have so little time, but I also know I've played like 3 clips. And by the way, I apologize if you were hoping for more. I'm going to play more, but we're going to go a bit after midnight, but still, I need to go a bit quicker. There's so many things I want to touch on, but I just can't. I'm trying to keep this one concise, fairly concise, for me, concise. But when we say, like, they go on to say, like, how do you know? His answer is basically like space-time emerges and like the curvature of space-time. There's philosophical reasons why we would observe like curvature or spin. We see spin on a quantum scale and curvature on a on kind of like a general relativity scale. Which is really just 2 different perspectives. It's not scale. When people say general relativity is about really big things and quantum mechanics is about really small things. No. That's not true at all. It's about perspective that's not size based. It's about, you would see the same symmetry structures if you're looking at the cosmos on a grand scale that you would see in the standard model if you were looking for in the right way, I guess. But it's about perceiving bits of information versus kind of like perceiving the navigation of that information. Is like the navigation is the space-time relativity model. It is the subjectively perceived perspective of someone navigating a bunch of information and relationships with other beings, but it's not just big things. But it's spin, like ultimately, like a universe is an information system that existence exists by definition, and existence is all that exists by definition, and existence is singular by definition because it is all encompassing of everything that exists, and it's singular existence. There's only one existence. That's what I'm saying. It's not 2 existences on a like cosmological level. There's just one existence. That is self-evidently super subjectively understood by everyone who's anyone to be an information system that we are, because there's information within it and we can perceive it and we are informed by it. But that information system is definitionally enclosed. Like because there's only one and there's nothing outside it. That means that it's completely self-referential on the most fundamental and most primordial level. It is a completely self-referential information system. Imagine it's the universe or existence is someone chasing their own tail ultimately, and so are you. Everything that you observe and conceive of and perceive and do is all understood by you in relation to you. And that means that, like, as you go through the world, you're you're constantly a dog trying to chase its own tail. How do I understand that? Well, because of what it means to me. That's what it means to have understanding. So every observation of anything ultimately ends with you contextualizing the information within your own self. It's like, I observe the color blue, that my room has been painted the color blue, and that's a physical observation, and then I understand it, that how it makes me feel, and it's like you can't escape this self-referential system. That is probably actually what is responsible for this spinorial or like curved perspective of space-time, but also spinorial, like spin structures within quantum mechanics. It's like, because the universe is spinning. It's what is this self-referential information loop that's entirely enclosed? It's informing itself about itself. That's what it is. That's what someone is. Anyone who's someone is a dog chasing their own tail, basically. And if you stop chasing, you would not exist anymore. So that is a philosophical idea that I have. That's like why I think that we see this structure all the time. And so they're like, why curvature of space-time seems to pop out of like, thinking about the universe as a neural net. It's like, they're going to get into the math maybe, but like I'm not literate enough in, but what motivates even the ideas that we try and look at mathematically, and which is just a language, mathematics. I can use a language, English, to also construct basically equations that are sentences and questions, and that's the same, but it is the same thing. And so I have that, I have this. That's my hypothesis. That's what I'll say, for that is the case. But that's his evidence that, like, for it being a neural net, is that like we observe curvature in space-time, and curvature seems to fall out of this. It's not the only argument that he makes. If I understand it correctly, that is one of them. You should watch the whole thing below. I'm destroying the arguments that he's making because I'm trying to summarize it and go quickly, and I'm actually just rambling, and it's not actually efficient. But we'll move on. Okay, how to get emergent spacetime. By the way, emergent spacetime falls out in my model as well, but it's just not in a mathematical way. It's in a symmetrical way, which is one of the things I showed you, that binary triality, length, width, height, past, present, future, that kind of thing. But this model, which is on my website, is just a model of a mind within a mind, and how there's like this overlapping interaction space that kind of is created. So if this is a mind that is imagine this is you and this is the universe. And so, or this is a cell inside your body, one of your blood cells, and this is you. And so this is a 4-dimensional mind, which is the 4 primary perspectives. And this is a 4-dimensional mind. And how you interact with each other is through these overlapping 3 dimensions. And so when you say like length, current, new location, current location, previous location, or length with height, you could even say, and time. This is your objective or sovereign constraint. It's something that is perceived as being beyond you. Time, which is causality beyond you, that is what time is. It's the causality that you have no control over, or that you can't stop. That's time. And this is the space in which you can navigate. Length with height, XYZ, new location, current location, previous location. One of them is a subjective or relativistic constraint, which is you can't escape it because of you. This is you can't escape it because of that which is beyond you. So you're always in your current location. You can't escape that. And your positive degree of freedom is to move to a new location, and your negative degree of freedom is to move to your previous location, which is really backwards and forwards in relationship with a goal. But you can't escape your current location or your current moment. Subject, then you have the being that you're within, the mind that you're within, and you have a past moment and present moment and future moment, which is, imagine like you're inside a mind, your mind inside a mind. What does that mean? It means that like as this mind moves, and really what that means is as this mind thinks, or as this being moves, same thing. There's no difference between your mind includes your body to some degree. It's not it's not defined by your body, but it is inclusive of anything that you incorporate into your information processing. It's not the same as a brain. You are a mind. You have a brain. Anything that you incorporate into your information processing gets incorporated into your mind as being part of your mind, or an extension. Like my desk is an extension of my mind if I'm sitting at it and using it. But so imagine though, this being that you're within is also going about its goals. It's thinking about what it wants to think about. It's changing what it wants to change. And what does that mean? It means, in this sense, it means like thinking or changing the information inside of it in a way. So as this being moves informationally, and you're within your world is the information in its mind. If your world is it, like the universal mind is our world. Like we have to navigate the mind of the universe. We are in it. We're like a sentient thought inside of a big mind that is thinking. And the information being processed by that mind, the thoughts of that mind will trump your thoughts. That's why you can't think a door red that you want to be red. You have to actually go and paint it red, because you have to conserve the coherence of causality within a greater information system. That means you can change it to red, but you have to like incorporate the information that has been generated by it. You cannot overpower the information that has been generated by it. So that which is the thoughts of the universe will be perceived by us as as physical constraints or concretized constraints, because the universe's thoughts are more powerful than yours, because they are our mind exists in their mind. Okay. And so, but what's interesting is that you have, space is how we perceive navigation within the universe, and time is that which we perceive as being caused by the universe itself. This is the universe moving itself. That is what we perceive time as, is the universe moving. This is us moving. This is the universe moving. This is the universe moving, it's moving from one moment to the next of its thinking. And we perceive that as our space, but it's kind of time. And so its space is it itself, is the structure of it, not the process of it. This is the process of it. This is the structure of it. And it is the objective constraint, because it can't escape itself, basically. Like it's the universe's objective constraint that it can't escape is space, which is itself. That's what it's basically, what I'm saying by that is it is its own constraint. Whereas on here, the universe is our constraint, which is time. It's the same thing. But this is just, by space, I mean like beyond its own being. I don't mean, it's like you can't escape yourself. You are always constrained to being within yourself. So is the universe. This, by space, I mean, that's what I mean. I mean metaphysical space, like the boundaries of being. But you have also positive and negative degree of freedom, and you have a subjective or relativistic constraint And that's the present moment. Like where are you in your processing now? And in the causative process right now. And so basically we perceive space-time, and the universe perceives time-space. And so this overlapping 4 dimensions here of mind causes this space-time to pop out, which is this triality of one form of observation of causality, and then one more perspective of causality that is not navigatable or overcomable by us. So you can change this stuff. You can't change that. The universe can change this stuff. It can't change that. God couldn't even kill himself if he tried. That's basically what it's saying. It's like the universe, but it's with us. It means like you can't even escape. You are always you. You can't escape yourself. That sounds like a terrible way of putting it. It's like obviously, but I'm just not finding the right words of it. But you have a boundary of your being, and you can't move beyond the boundary of your being. That's all I'm saying. That is responsible probably for like the causation of our perception of the perception of space within that structure. So our cells perceive space as the boundary of space-time, their space-time, which is the boundary of your body, basically. And that boundary is created by the boundary of your being, your metaphysical being, your someoneness, not your body. Okay? Because if you were to leave your body and die, your cells are no longer able to perceive like the boundaries of their being, of their space-time anymore. They're just going to start to fall apart, and there's no containment anymore. There's no world that they have anymore. Their world fell apart. Like that's what happens when you die. Is the world that your cells exist in falls apart. People would be focused on the body. They'd be like, the body is still there. It's like, no, not for long. Like it's actually gone. It's just like we just need to wait to see, like to see the reality of it being gone. We just have to wait. But it's gone. Their world has already fallen apart as soon as you die. And if the universe was, able to die, like if it did, and we're inside of its body, we're cells inside of its body, our world would just fall apart. But I don't think that can happen because God can't die, because existence exists, and it's a self-referential information system. So, and it can't not be. So, thank God for God. But that's what I mean is like I know that that's not how that's not the models and the language that he's going to use, or even the examples that he's going to use of how space-time falls out of this, the idea of us being in a neural net, which is like the idea of the universe thinking. But I'm confirming that my own work is showing the same thing. The 4 primary perspectives are the beginning of are the foundation of thinking. They are the foundation of conception and perception. So therefore, the foundation of thinking, and that they are what causes this. We're a mind inside a mind, and it causes space-time. The perception of causality within that is navigatable by you, and the perception of causality that is beyond your ability to navigate. It's fascinating. And I'm not like trying to say this of like, oh, I said this too, I said this first. like this, I'm not, who knows? It doesn't matter who said this first. I don't have no idea who said this first. The first proton, probably, like God, like it's not about that. It's about, we are starting to see people propose ideas in physics that really seem to be inescapably supportive of the idea that we are inside someone, that our universe or that existence itself even is someone, and that idea is very, very, very powerful in our ability to make prediction models that are accurately predictive and consistently predictive of what we perceive. And that's wonderful, because that means that physics is starting to actually has a chance at becoming sane again, coherent again. But it requires a few things that it doesn't currently have. One of them is the realization that that a theoretical physicist is a philosopher, and you have to admit that you have an assumption that you will never be able to necessarily prove if you're looking for fundamental theory, but something that we're looking for something that we can't help but constantly confirm everywhere. Okay. I love this. Because we're going to go on a bit later. I know I'm going rambling, but it's so good.
So, because if you talk about gravity, it's very important to think about how you actually define entropy. This is, now you have a space that is curved. Now, if gravity pulls things together, wouldn't it mean that the entropy decreases, right? So you have kind of, before they would be distributed everywhere and they're pulled together. Now, naively, you would say it decreases, but then you say, well, no, I'll define entropy a different way. I'll catch the problem, so that it doesn't. But again, if you only pay attention to one number that you want so badly to increase, then okay, let it be. I'm saying that the usefulness of second law of thermodynamics.
Okay. Again, to not be like I've been saying it, but there's something that I don't talk about on here very much, and that is that when I first had this epiphany of this idea in 2017 or 2018, way before this theory was called Sentient Singularity Theory, but when I first started thinking about this conceptual models and I was investigating physics and learning about physics for the first time, I had an epiphany about an experiment. And I'm not saying that it's even possible to physically test this. I don't know, but I have it. Actually, I wrote it down many years ago, many years ago, like 2018, 2017, 2016, something like that. And it's actually been, I don't talk about it on here very much, and I don't know why. I think it's just because, actually, I do know why. And the reason why is that, and I'm going to show it for the first time in a very, very long time. I don't even remember the last time I showed it. It was many, many years ago on here. And it's very rare. And it's only for the people that stay up late and are actually, committed to listening through my side tangents. They want to understand this stuff actually, truly enough so that they will put up with my rambling. The real ones. So if you're here, thank you. This is what I will show you, is this idea for an experiment. And the reason why I didn't want to show it why I don't show it often is because I don't want somebody to do it without my narrative included. And it's not because I care about getting recognition. It is because I don't want them. It's like the Jurassic Park thing. It's like there's a level of between wisdom and understanding. There's a level between curiosity and understanding, or curiosity and wisdom, where it's just understanding enough to do something to be able to do something, but not actually to understand it. Maybe to understand it well enough to do it, but not understand it well enough to see its implications. And it's the Jurassic Park thing. You were smart enough to figure out that they could, but not wise enough to figure out whether or not they should. And it's for measuring gravity, basically. It's an experiment to measure gravity, basically, in circumstances where I'm predicting there to be some type of nuclear binding energy or the equivalent, and that are beyond just atoms and molecules. And what this nuclear binding energy is it is the force that holds protons and neutrons together. That's nuclear binding energy. And one thing that's very interesting is there's something called mass defect. I haven't even spoken about this in so many years that I'm hoping that I get all this right, because I wrote it all down many years ago. And mass defect is the difference between the measured mass of an atomic nucleus and the sum of the individual masses of its protons and neutrons, of its constituent protons and neutrons. What this means is that when you take the mass, you take an atomic nucleus and you weigh it on a scale, it will weigh less than, it will have less mass, actually, than if you took the individual protons and neutrons that made up that nucleus and you weighed them individually and just added it together with a calculator. Which is like, why? And there's equations that are cited as explanations that are not explanations. And there's more, there's physical descriptions of those equations that are cited as explanations that are not really explanations, like real explanations. But I think that this is what happens when you have a being that is a sentient singularity stacked on top of an assembly of sentience, basically. So when you take that, what this means is like the cells of your body, if you took all of their mass, which is like gravity, really, like that's where we measure gravity through mass, basically. And you added up the mass of of every individual cell in your body, and then you weighed it again, and you took that number, and then you took you and you had weighed yourself with all those cells, and you just weighed yourself on a scale. You would weigh less. That's my prediction. And there was an experiment that was done in like the 60s that was trying to measure the mass of a soul. And they basically were weighing people at the moment before they died, and they were predicting that people would basically get lighter when they died because they predict the soul had weight. And I think that this is wrong. The prediction should have been the opposite, but you wouldn't be able to necessarily even to perceive it on a scale the way we think of. You might have to really think about what it means to measure entropy, which is kind of the opposite of gravity. Gravity pulls things together, as Vitaly stated, and entropy is about breaking things apart. And but my prediction is the opposite of this experiment in the 60s, which they claimed to have seen what they were expecting, that somebody got lighter when they died, and then they tried to reproduce the results. They never got it. I don't think that they ever could reproduce the results because, for one, I don't even know if like a normal scale, even if it was super precise, is the right way to think about it. But you might have to isolate what you're looking at in a way that I don't quite understand yet. And that's another reason why I don't talk about this yet. But also that I think that they were wrong about the predictions. Gravity is the universe's movement and technically also the movement of everything and everyone basically inside it. And so gravity would decrease as agency increases. That's what I'm trying to say, is that an atomic nucleus has more sentience, more of its own will, and that is animating it, and therefore requires less will to animate it, less of the universe's will, less of God's will. Okay, and so it's like if your kid is learning to ride a bike and you have to push them, you have to hold them up in the beginning and push them. But as they get better and better and better and more aware of everything involved with and more self-animating, you can let go and push a little bit less. And so that pushing is gravity. That pushing is the universe moving. And it's the animating force of the universe. If you think about what is the force that is actually causing things to be animated beyond the individual wills of the things that exist within the universe, it is the animating force of the universe itself, which is the universe moving itself. And that is gravity. If you actually think about it philosophically, you actually understand you can actually really understand what that is that it is gravity is the universe moving. And so I wrote down this experiment, and I'll show it, I guess. Actually, I don't know if I'll show it right now. I don't want people to do it and then misinterpret the results. That's my point. That's my fear. It's not that I think somebody's going to steal it. I don't care if who gets credit. I want to make sure that what is interpreted by this is the actual is the idea that I had that actually would led to the construction of the experiment. And that's very important. You have to know why, and that's where an idea came from in order to be able to explain the implications of an experiment that came from an idea. If it wasn't your idea that motivated in a certain experiment, if somebody else's, and they just told you to do it, but then they weren't around, the person who thought of it wasn't around anymore to explain why they even had conceived of this experiment and why the results would be the results that they are. It is guaranteed that they will not be explained properly because the context is missing. That's why I'm a little bit hesitant to show the entire thing right now. But if anybody is interested, I will 100% be showing exactly the more details of the experiment later. But it's basically that. It's basically a way of measuring in other instances besides atomic nuclei, looking for mass defect, including humans and cells and any beings that we assume to be beings. Basically, I think mass defect exists in them as well, and that idea came from exactly the idea that Vitaly is stating in the clip I just showed, which is amazing. And it's awesome because the first audio clip that I showed of this podcast in this stream it starts with, when you stop laughing, which is like this.
When you stop laughing, I will explain to you exactly how I did it. I was trying to understand. When you stop laughing,
they were terrified of my idea, these physics and math PhDs, and they said it. They were like, they banned me. They were like, I need to protect people's ideas, and this person, Tyler, is too articulate and good at. He's much more convincing than most other crazy people that come in here with the idea that there's willful agents even on the atomic scale. Because I said a proton is probably a sentient being. They were like, nobody thinks that. And I'm like, well, I do. And Maybe I'm right. But that all of that is very relevant to why I came up with this experiment idea. Is that there's the more agency or consciousness or conscious that I hate to say the more conscious, the conscious or sentience, you are either sentient or not. You're not more sentient or less sentient, but there are instances in which sentience gets cooperatively added together, basically multiplied by a bunch of cells coming together, and then also stacked on top of those cells is another sentient agent. But then there's also just instances of a bunch of cells, like a heart. It's like a heart does not have a sentient agent stacked on top of it. But it's just a perspective of like a bunch of cells. But then there's like you as a bunch of cells, and there's a sentient agent stacked on top. And so every time that this assembly and then stacking happens, call it multiplication and stacking. Your cells are multiplying, and then stacked on top of them is another entity. Every time that happens, which I think is when protons and neutrons come together in atomic nuclei, and then it scales up. I'm not saying every single, like this is not an sentient assembly. There's no one stacked on top of the molecules in this pen, and they're not working together for anything. They're not animated. There's no will to the molecules in this that has anything to do with the pen. There might be, if they are sentient beings, they might have their individual wills to persist and to exist, and they eventually die basically fall apart due to entropy, just like we do. But with like a frog, those molecules do come together into cells. So there's the agents of the molecules, then they come together and they're stacked on top of them when there's a cellular agent, and then those cells come together and then stacked on top of them as a frog or a human or whatever. And this is the increasing of your own will, like agentic, willful power. And as you get more of it, as a structure gets more willpower, basically, internally, it requires less willpower externally to animate it. Does that make sense? And that external willpower is the universe's will to animate within itself, to move information. And then, but we have the same thing. We're just inside that process. And so as we get more self-animated, it doesn't need to animate us as much. It's the opposite of that experiment that from the 60s or whatever that they were expecting to see, like that the soul had weight, and that when you died, you would get lighter. Conceptually, according to Sentient Singularity Theory, any being that dies or that is disembodied, that structure that's left over of other sentient agents that made it up would actually get heavier, not lighter. So like just conceptually, what you would actually expect to see when somebody died, if they were on a perfect, like a scale that could measure this, just, however it's done, you would see them get lighter when they were alive than when they were dead. So you would see them when they died, you'd see them get heavier, not lighter. It'd be the opposite of what the person was expecting to see. I don't know if that's actually measurable from the perspective of like just weight on a scale. But I do believe that there is a way of seeing this. And to some degree, there is a way of seeing the efficiency of a system that is a sentient assembly system that is much more efficient than a system that is not entangled. So for instance, like a married couple is economically efficient compared to two unmarried people who live together. Two unmarried people who live together have two beds, and they have they don't shop collectively, and they don't actually produce anything beyond them. They're not productive. They just are kind of maybe cooperatively offsetting a little bit of they're cooperating a little bit, but like they don't have shared fate. Whereas like a shared life path, basically, and shared goals that are actually going to be like have productive possibility. But like a married couple does. They are negentropic, a married couple. Basically, they are able to overcome entropy, especially by just reproduction. But like two roommates, they can just make their lives a little bit like easier, but they're not unifying into one. So they're basically, because they are not unified into one, they end up they're not on the same, they don't share a fate, which means they don't share a will too. So you can see kind of like when beings come together into like what I would call sentient singularity versus a pseudo singularity, or something like a corporation or like a roommate situation or something, coworkers, you would see very different things. And so I have an experiment to test both of this, and it also will look for instances of what I call a pseudo singularity, which is like organisms. There's sentient singularities and pseudo singularities in organisms, I believe. Like I think that an earthworm is a sentient singularity, but a planaria worm is a pseudo singularity, and a married couple is a sentient singularity. And but it's just hard to see that because you're the cell in this you're a proton looking for the nucleus. You can't see the being that has been created as that you're part of. And so a pseudo singularity is I think you can use this experiment idea that I have to like look for it, but you have to know which instances to look for, instances to look at and test, which would be like a planaria worm, and which is basically, it's a test for sentience. That's what it is. But sentience is animation, is animative power. It's willpower. It's will to power. And gravity is that too. It's just of the universe. It's just how we see the universe is willpower from being inside the universe. It's fascinating, but this idea that gravity is the opposite of entropy is exactly the idea that motivated my experiment, which is, I only have really one experiment, and that is like an experiment idea, and that spun out of this. And I don't share the details of it yet, but I will. I'm telling you the concepts that are related to it and basically what you would want to do, but I'm not, I have a little bit more detail. And I will share it with anybody who wants to work with me on doing the experiment. It's not for credit. It's for context. Credit would be nice, but I don't need, I want to work with other people. I'm not trying to be like, I'm going to be the one. The most important thing is context. And you can't actually have context without some credit, because you have to explain what motivated the idea that this would be the result of this, and motivated the idea to construct this experiment in the first place. That involves like credit. So just for some context, I really love this conversation between Curt and Vitaly, because it just shows where we're actually heading, and so shows that physics is about to it is having a revolution. It is going through a revolution, and some people don't realize it yet, and it's the people who are going to be, probably just left behind. But they're physicalists, or they're people that I hate terms like that, but there are people who believe that sentience is not primary, and that it is emergent from non-sentience, which actually doesn't make any sense in any way that you think about it. But we don't have time to explain all the ways. You could just subscribe and tune in every week, and I'll do it every week. Okay, let's go to any other clips, because I'm trying to show more. Just know, if anybody wants to work with me on that experiment, I will show you all the details that I have laid out. It's not done. I need help, but it's also not probably a multi-billion-dollar experiment. I don't think it requires Hadron Collider. I think it requires a well set up, actually fairly cheap experiment. Fairly cheap, I don't know what that means, but it doesn't mean billions. Okay.
Yeah.
But it is looking for the idea that sentience is related to the animative energy that is the opposite of entropy.
For many subsystems, very successful.
Okay.
And then but there are certain things that with this you will have hard time explaining. And as a cosmologist, I have to say, we have one beautiful theory in cosmology called the theory of cosmic inflation. That is kind of is hope.
There's so much to this. I don't have time for it though. Let's see. So again, my experiment is basically assuming that subatomic particles of protons and neutrons are sentient, not electrons and not neutrinos and not quarks. I have a different idea or proposition of what those are, each one of them, but they're not sentient beings, holistic sentient beings. They're like pieces of a sentient being. It's like looking at a toe of an elephant versus an elephant. And whereas a proton would be like looking at an elephant, an animal holistically, whereas you're looking at someone. Whereas if you're looking at an electron, you're looking at someone's toe. And if you're looking at a proton, you're looking at, not a proton, a quark, you're looking at someone's finger. Like that kind of, that's not all of it. It's much more rigorous. My propositions for what they are, but that is just a conceptual explanation of why not an electron, and why not a quark. What these really are points of perception, and so or points of force. Like a quark is I call them force points. They are a point of force. That is what they are. If you think about it conceptually, you understand what quarks combine into, and then what defines that. It's a point of force. And what is an electron? It's a point of perception. That's that makes sense with the entire model of and the issues with measuring its position versus its momentum at the same time, or whatever it is. Like that indicates that it's a point of focus that is not separate from the constraints of your own mind either. Whereas like a quark, because of what it sums to and what it ends up doing and be constructing, is very obviously like a point of force of the universe itself. It's like a finger of God, like pushing somewhere. And but those are not like going through evolution. That's why they're elementaries. They're the same every time you see them. But protons and neutrons and probably, and atomic nuclei almost certainly. These are probably beings like cells and like animals that go through an evolutionary or an adaptive change process, that basically just they go through change as they pursue their goals and they change across generations due to external pressures. That's all that means. And I've said that. And in that same conversation that I showed, played a clip of the audio from that Discord where I was like, this person who I won't play their voice because I said to them I would not, said, no one thinks a proton is a sentient being or hadron is a sentient being. And I said, I think they probably are. And, you know, this next clip is relevant to that.
That natural selection operates on the level of subatomic particles.
Am I shaky in my recollection? Not from this conversation, but somewhere else.
No, you absolutely. It may have not been in this conversation that I said that. I certainly wrote about it in the papers, and yeah, and so this natural selection, like whereby natural selection, I mean, the more useful configurations of networks survive because they help loss function to be minimized better, and the other configuration will not survive. So in this sense, natural selection, those architectures that are useful for learning will stay, and those who are not useful for learning will be removed because they are not their loss function is not as low as it should be. So in this sense, yeah, but it doesn't work just on the level of particles, elementary particles. Remember again about this analogy of the right language on different scales. So if you want to talk about this at the level of particles, yes, you would say particles.
I love that he said the right language at different scales, but there's also certain fundamental language that would be consistent across scales.
Such, the way they are is because they underwent the series of natural selection of their scales and figured out that this is the states, this is the state of their neural networks that describe them, that are allowing their loss function to be the smallest. But this is can be this argument, this natural selection argument, or I call it more learning argument, right? So you're trying to minimize something. It can be applied to any scales. It can be applied to scales of biology, which we usually do when we say natural selection. We usually think about the scales of organisms, right? Organisms again, some kind of configurations. They are more maybe fluid configurations because no two organisms are alike. But so maybe particles, right? So they look very similar, like all electrons look very similar, but we don't know. Maybe there is some tiny difference, and then and the way we are trying to understand the tiny difference, or maybe it's already went through this very long period of natural selection, and then that is the value. That's what electron mass should be, and there's nothing else I can do at this point.
I imagine if you could put a mark on an electron and a boson and distinguish them, then the spin statistics theorem wouldn't apply anymore, and we would see some effects of that.
Right. So the loss function would be, it's just not convenient for not to have fermions. And again, we kind of understand that. I think one good example I can give that maybe a very general audience will understand, and machine learning people will definitely understand. Cars, and moving in the traffic, and they're trying to self-driving cars. Right? So we assume we're 10 years from now, where all the cars are self-driving. Maybe soon.
So agents, basically.
And then all of them are driving, and they're all trying to optimize their loss function. But to optimize their loss function, they have to do some calculations about the environment. They have to scan the environment, find something, plug it into maybe their network, and then network will say turn left, turn right. And so, and at this time, that information that it collects, each of the cars collects, we actually call in the physics of electrodynamics, we call that bosonic field. So it's electromagnetic field, or green function of other electrons that I scan around propagates to me, and that gives me relevant information for what me to do as an electron. Or cars scan around for other cars, get that information, and say, okay, that's the relevant information to me for me to make left, right turn, or accelerate. So in this sense, cars are like fermions. They are advanced enough to be able to process not the state of the entire universe around them because they are tiny, but relevant information for them to optimize their life.
I mean, or it's just like we're only looking at like a. Imagine you're just like looking through a telescope like this or tube at the universe, and you can only look at a single moment at a time because your mind has a constraint of focus that is just falls out of the fact that you can only have one goal that is primary, and you can only because you are only someone like that, you can only focus on one thing at a time. Anybody that says they can focus on two things at once, they cannot. They cannot. Kanye West, he says in a song, it's like, it's, you know, not the most like modest line, but it's still, I love just like, it's just brilliant. He's like, I love, he basically says, I love boobs because they show me that I can focus on two things at once. I think he says titties, but like, he's like, I love that they could show that I can focus on two things at once. And it's a brilliant line. And, but it's actually false because you're conceiving them as one structure. You're not able to focus on both of them at the same time individually. You have to just be like, that's one structure. You just expanded the boundaries a bit to encompass both of them. But it's like, you know, you can say I can focus on a car, but you can't focus on the tires and the steering wheel at the same time. But you can like back up and like look at the car and be like, I can focus on the car. But Kanye would say, I like cars because they prove that I can focus on steering wheels and tires at the same time. No, but nice rhyme. So this, but that has implications about like, that I think it's not that there's fermions, even if they would probably just are individual perception or individual points of force that are coming from a single structure, or our individual perception of specific parts of a greater single structure, like the one electron universe theory. I don't know anything about it other than the term, and I've heard people say that some people believe in one electron universe. That doesn't really linguistically make sense, because like an electron is defined as being like piece of the universe. So, but the idea that like there's only one thing that you're looking at, just looking at it in different parts of it. With the when you look at an electron, you say, I look at that electron and that electron. What I'm really looking at is two different parts of the universe as a whole, and which is really like a mind that is going through the process of thinking and or at least of processing information. But it's a single structure that you're looking at, but you're just looking at two different points of it. And yeah, it's interesting because like you couldn't observe more than one electron at a time, I don't think. You could like conceive of it, but like you can't perceive of it. If you could have a camera that would actually zoom in close enough, and or a lens that you zoom in close enough, I bet you could not look at more than one electron at a time. Assuming you could see it. You would never see like multiple electrons next to each other. I don't think. I might be wrong, but still, regardless. But what he's getting at, though, when a better example than thinking about electrons and bosons that Curt and Vitaly are talking about, is just thinking about the atomic elements, atoms. Thinking about atoms and the different elements. All atoms were basically once hydrogen, then helium, then on and on and on and on and on, as the pressures changed of their environment and caused them to change across lineages or across change on a lineage level, basically, like change intergenerationally. That's like a much better way of thinking about the evolution of cars, the change of maybe not. He's thinking about like cars navigating, but I'm thinking about like us changing cars as to navigate the world. Like there's different generations of cars. 2022 Toyota Tacoma. I want one. They don't come in green in 2026. I don't know why, but maybe not enough people bought them. And so selective pressures made it so that we're not making green Toyota Tacomas anymore. I don't know why, but that's that's like a better way of thinking about this. I think that you would be more fruitful. But but the fact that he's thinking about like these processes and animation, like agentic like the idea that there's agency basically on scales that are below cells, which is not currently assumed in our scientific general narrative, is aligned with what I've been saying as well, even if I'm going to say it starts probably at hadrons instead of electrons. But the idea that he's even saying, like, they went, maybe the idea, there were previous, like, examples of different types of protons, and we're just, now they all look the same because of maybe they went through a evolutionary process. That isn't a bad idea. It's a good idea. I don't think that that's true, but I think it's a good idea to apply to certain contexts. Probably not that one, and probably not electrons. But still, maybe some other people are about to start thinking that a hadron is a sentient being. That's my point. Anybody who understands natural selection really well, like firsthand, not just learned about it in school, but like me, who has actually like studied populations of animals over time in a space and seen them change, and understands like a lot of many different types of animals in zoology. I'm still a zoology person. Yeah, I will never not be, even though I chose not to abandon it academically. I still study with like some of the top zoologists in the world. And I've been out to study sites, and I've also seen people breed animals in captivity, and so across multiple generations, and seen change. And so I know, like, firsthand, I've seen a lot more application of the concepts that most people just talk about in like Mendel's P's and Punnett squares. Like, I've used those things in real life to change animals over time, and watched them do it in the wild and in captivity. When you understand evolution not as a term, you understand it as a process, and or adaptation as a process, not as a term. And then you can actually see that process in other circumstances beyond just the one that you were told it exists in school. Like, how many people watching this have actually seen like intentional selective breeding of animals across decades, in a single lineage? Like, you knew the parents and the parents and the parents and the parents and the parents. Not like you're aware that people breed dogs and stuff, but like you've seen the parents of that one, of that chicken, and that chicken, and that chicken, and that chicken, and then generation after generation after generation, going back like 20 to 30 years. That's different. Like, you start to really understand the process a lot more beyond just a term. Your ability to repeat a definition from the dictionary is not the same as understanding a term. Okay. Next clip, and then we'll go to the chat, and then I'm going to try and wrap it up.
Out of the way. And thank you for that, by the way.
By the way, this is the question. I don't like the term consciousness. I like the term sentience. It's more fundamentally relevant, and it's clearer also. It doesn't have multiple meanings like conscious does. Conscious can mean awake versus sleep, but both of them, you're still a sentient being. But still, this question that Curt is about to ask is the question. It's the question that is what differentiates like Sam Harris and from anybody who is actually able to take this idea to its ultimate conclusion.
Let's get to
consciousness.
is the universe itself in your model, with the universe being the neural net, conscious?
Okay, very good question, and of course I get this question all the time. Now, here is my maybe a bit longer answer, but I think I need to say that. You come with the mathematical framework, new mathematical framework, which is very rich, which is it relies on neural networks and the learning dynamics, and you're trying to use that to describe some phenomenon. This phenomena may be physical phenomena, like we talked about, or the phenomena that people are discussing in other branches of science, like consciousness. So they already have a term for something, and you're bringing a toolbox. You don't, in this toolbox that I have of learning theory, there is nothing that I would call consciousness, but I'm trying to use it to describe what people mean by consciousness, and I can have many attempts. So I may suggest something, and they will say, well, this looks like not a good definition of consciousness because here's the system that we all agreed, 100 of us agree that is conscious, but your system, your definition tells it it's not. Then okay, then either I say, well, maybe you should adjust your notion of what consciousness is, or maybe I should adjust my definition of consciousness. And both ways are fine. Now, my definition of consciousness comes from how I understand it, how I can build it within framework that I understand, mathematical framework. And in this mathematical framework, system undergoes learning dynamics, and there are three macroscopic things that are directly related to learning that I can calculate. So one of those things is how fast system adapts to the new data set, to the new environment, how fast it learns. So this is I can actually calculate it, is the decay rate of the loss function.
That sounds to me more like intelligence than consciousness.
Right. And well, okay. So, but then I say, hold on the intelligence because I have comment about that as well. So, and then I'll say, I wanna, as a hypothesis, call the risk rate of decay, how fast, I wanna call it consciousness. Now, maybe it will be wrong, but I will call it, because I come with a new framework, and this framework I can calculate this. But I say right away, there are two more things that are also macroscopic, and some people may relate it to things related to consciousness, but I would relate it to intelligence. And I would say actually three things contribute to intelligence. If you judge a learning system, how well it behaves, then there are three quantities you have to calculate. One is how fast thing learns, and I call it consciousness. Maybe you would call it intelligence. Second thing is how low does the loss function go asymptotically? If I had infinite time, how will it go? Yeah, it may learn fast, but then just stop. So I would say, okay, that's another ingredient that is important. How low is a loss function? And the third one is once it's reached this asymptotic loss, it's not going to stay there. It's going to be fluctuating, because that's what learning activation dynamics. You just don't stop. You never stop. You're always in this learning equilibrium, and sometimes loss goes a little bit up, down, so you always fluctuate. So how big are the fluctuations? So then I have a learning system, and I can calculate three things: how fast you learn, how good you learn if you had infinite time, and how stable what you learn. And so I would say that because of that, those three things, I actually describe what I think is intelligence, not just one IQ number. No, three things. And then you can have different people. Some people learn very fast, but they stop. They are not learning more and more. Their loss function is halted. Other people may take a very long time to learn, and then eventually they end up knowing all of the differential geometry and quantum field theory, what's not. And then the third type of people who maybe also learn fast, and maybe they know all of the advanced mathematics, but they're very unstable until they keep repeating it. They keep forgetting, and then opening your book again. We all forget stuff, right? You learn something. I forget the things I wrote in my papers, right? There are many papers I have to look up. So there's some degree of how my knowledge, my loss function, is actually fluctuating. So I would put those three things. I would put those three things and say that's intelligence. At least three. So it's at least three, maybe more, because actually.
That's brilliant. I talk about that is like there are things that I don't. But here's the thing: I don't really know how much there is a limit to anyone's. I don't. It's brilliant to conceive of intelligence as being this triadic confluence of abilities, but because I was always tested as having very slow processing speed, but I also know that I am a much deeper thinker than most of the people who I know who have fast processing speed. And actually, there's probably not always, but there's probably often, the more you have deep thoughts, the slower you think, and the more shallow your thoughts, the quicker you think. But it's really, that's a perception problem. It's because you're thinking about less. And so it's not faster thinking. It's just you're thinking about less. And so it's about like your processing speed. It's like the people who process things very quickly do not like, or who act very, very quickly and like almost instinctually in certain circumstances. They are not very, a lot of times they don't think about consequences, be like ultimate consequences. They think about just proximate consequences. If I do this, then this. But if I do this, versus if I do this, then this, and then this, and then this, and then this, and then this. And so like, should I do this? And so if one takes you a while to decide, if it takes somebody longer to decide whether or not they should do something because they're thinking about, if I do this, then this, then this, and this, and this, and this, versus somebody to think about, decide, and make a decision on, should I do this? And all they're thinking about is, if I do this, then that. Or that. If I don't do this, then that. Okay, so I'm going to do this. They're not actually thinking faster. They're making decisions quicker, which really is like, your thinking is really a series of decisions in many ways. But and so I don't really know if processing speed is able to be measured, and if there even is a processing speed. I don't think that there is really. I think that the level of information that's actually fundamental, like metaphysical level, or an informational level, is beyond the context of speed. It's beyond relativistic conceptions: faster, slower, bigger, bigger, smaller, heavier, weaker. It's about very clear. It's about relationships and clear differentiations. Inside, outside, separate, and oneness was created by, I thought about that. I realized that idea, those four primary perspectives, because I was trying to come up with a way of, I remember hearing somebody say, like Eric Weinstein said, we have to figure out a way to, like, we're stuck within a conception of space-time within relativity. I was like, how would you even conceive of orientation in a system that doesn't include any kind of relativistic conceptions? And I was like, well, inside, outside, separate, and oneness, that's also how we understand ourselves versus everything that's not ourselves. And everything that is anything that is defined by us as a thing that is distinct. This is where does the knife on this or the screwdriver on this end, and the the whole multi-tool start? Where does the knife end and the pliers begin on this multi-tool? Well, you're like, the knife is inside of the multi-tool, and so are the pliers. And they're one with like this. They're all one with each other within the context. They are within one, but they're not one with each other. They are separate from each other. The knife is separate from the screwdriver, but they are within one tool. Just like, so like, this is about your mind, again, differentiating different bits of information, organizing it into a symmetry structure. So like, I think that we are, like, on that level, there's no relativistic conception. There is no speed of intelligence. And I don't think there's a limit to what your ability to think about is. The idea that there's oscillations between, in learning, where you forget certain things. And so like, you have to relearn it. I can do that sometimes. I also forget things that I write in this paper that I'm writing. It's part of why I'm so slow at it. Because I'm so focused on individual aspects of it and not it as a holistic thing. And I'm working through this. That I am not able to focus on, you can only focus on one thing at once. That's just the definition by definition. And so, but I don't think there's a limit to our ability to understand things, actually. I think that if you gave somebody, we exist within the context of space-time. We're embodied within the context of space-time. So we have to, which is really just means that there's other beings that, creating causal chains of effects around us that are beyond our control. And because of that, we have to move at a pace that allows us to achieve our goals within the context of other causal chains happening around us that we didn't start. And that causes a circumstance where you are constrained to space-time. You have to think fast. But it's like, if you didn't have that, everybody just thinks that, I think, would think at the same, thinking would be just thinking. And if you also didn't have distractions, then you wouldn't have that oscillation of forgetting. It's not forgetting versus remembering. It's about focus. It's about shifting focuses. And if you don't shift focuses, though, and you don't have to contend with causality, individual causality chains, different causality chains from somebody else, and then I think thinking would just be the same for everyone, and we would all also ultimately be able to think to the same level of depth. That said, the actual difference is, are you actually has to do with awareness or practice of the thinking process. Are you aware of what it looks like when you fail at thinking, or when you succeed? And do you know what that intuitively, have you learned what that action is of thinking? And that's why one thing that I've always been very good at, and just not to like be, I'm not saying that arrogantly. I'm saying that confidently. It's a quote, the same exact like audio clip of me speaking to those physics and math PhD students, is I am a good thinker, but I'm also always been slow thinker. And I'm also somebody that has to relearn certain things again and again and again. But certain things I learned once and never forgot. And those things are oftentimes things that other people could learn, and they will never, they will forget it immediately as soon as they take the test. And the reason why is because interest and relevance, it's not relevant to them beyond a certain individual circumstance. Whereas like for me, certain things would be much more relevant. Whereas my brother has explained things to me about sports team, about basketball and baseball and football so many times. Some of it I get eventually, but it's my only context of that, of a lot of the things that he tells me about and the people that he tells me about in baseball. My brother's like autistic about baseball. He's like, I am with animals. He is that with like the whole history of sports. He knows every player that's ever been relevant and their entire history and like stats and it's wild. But I can't memorize that stuff, even though he talks to me about it all the time, usually, because the only context I have of it is just that one moment. Same thing with me and animals. I tell him things and he eventually remembers some things, so I say it enough, but a lot of things it just goes like this. It's because he doesn't have actually like individual context for it. And so when you lose that circumstantial context, it's gone. It's like when you learn everything for the test, you take the test is over, you walk out, you literally will forget basically everything after that, because the context of that information is gone to you. But if that test was on something that is like going to be used by you in your career forever, you'll never forget it. I think that the fact that he's seeing that there's this trialic aspect of how we can perceive the implementation of intelligence or the application of intelligence is actually true to the structures and symmetry structures that I see in Sentient Singularity Theory. So it's not wrong, but intelligence is the ability to accomplish a goal. And And I think that we all have, you can train to be good at thinking. You can have an 80 IQ and be a better thinker than somebody who has a 200 IQ. And you can actually end up solving problems that they never could, understanding things they never do. If you have true context that is complete enough, enough interest, and you are actually thinking properly. People who have really high IQs can think that they're thinking about something, but they don't understand thinking because they're just have sat in a desk and memorized and repeated things for a very long time. It's not everybody with a high IQ, but like I'm saying though, you're not constrained as much by these like attributes of like, are you fast thinker even? Not even just your IQ score, but like, are you also a fast thinker or are you slow thinker? Do you have slow processing speed? It's like, do I have slow processing speed? No, I don't think it's perceived as that in the moment, but really I'm processing a lot more than most people in the same time span. Or not in the same time span, a lot more than most people before taking an additional action. That's what it is. And so people who are thinking about less will take another action quicker than I do in the same time span. And it looks like they're fast thinkers, but it's like, maybe we could call it that, but internally that's not really, I don't think we're really different. I think that thinking is thinking, and it's about awareness and context and practice and will more than anything.
There are more because, it's a stochastic variable. There are statistical moments, first, second, third.
But again, he hasn't really answered the question yet, but that's why I'm saying is the better question is the universe sentient? Not is the universe conscious? Because like he's talking about like, okay, consciousness, I'm going to define it here potentially as like, your ability to decrease your loss function, basically how are like to minimize entropy, the minimization of entropy. I think also who says this, there's a physicist he did My Big Toe. He that's forgot the guy's name, but let's look at this up. My Big Toe, My Big Theory of Everything. Tom Campbell. And a lot of people tell me my work reminds them of Tom Campbell's work, but Tom Campbell thinks that every being has the goal of minimizing entropy, basically, which is like to minimize its loss function. That I think is wrong. Every being, everyone actually has the goal of probably maximizing their meaning. And that's probably what it is. And that minimization of entropy is or even the overcoming of metaphysically of entropy by like, having a permanent impact on someone else that can't fall apart because it's permanent for the duration of somebody's life. And maybe having children allows your agentic chain to overcome entropy. You don't, your body doesn't, but like you did, you beat it. Even if you just make a permanent impact on somebody, like you made on somebody's life, it's still in a metaphysical way, like you overcame entropic forces, which is like just destructive forces. You built something that lasted. You did something that lasted. And never ended, like really, because it's just, you can't keep somebody alive forever, but you can definitely make a permanent impact on them while they are alive. Probably that persists even after, but regardless, my point is that the minimization of entropy is a byproduct of the actual motivator and goal of any any willful being, which is any being, any someone, which is the maximization of meaning, probably, which is the impact, the wanting to maximize your impact on other someone's. But yeah, like reducing your entropy would be a byproduct of that. Like I said, a married couple is economically efficient. It's the most economically efficient, like, social structure. It's not like, oh yeah, like me and my friend are going to move in together because we can't pay for our own places, so we're going to pay to rent a place, and we'll share a fridge and like a TV, but like we won't share beds, we won't share bathrooms, we won't share bedrooms. But eventually we'll also just leave, and we will end this circumstantial sharing or efficiency relationship, more efficient relationship, economically efficient relationship. A marriage structure never ends the economically efficient relationship. It starts and it becomes as economically efficient as possible. And then not only that, having children allows for the next generation to support the elder generation and work together to overcome entropy, basically. Like it is the only structure that actually allows for like a permanent efficiency. Everything else is a temporary relationship. But it's defined as a circumstantial relationship. That economically efficient relationship is not going to be permanent. It doesn't have the definition of being permanent outside of marriage. So like this is when he's talking about beings coalescing and then becoming, economically efficient, basically, like reducing their entropy. I said this about cells earlier as well, is like you die, your soul leaves this body, is disembodied. Your cells are done too. Like they don't continue. They're not like, okay, now I'm going to go do my own thing because I don't have to serve the king anymore. And now I'm just going to go and I'm going to be a piece of bacteria. No, they're all going to die. Because there was a permanent relationship model there that was an assembly within a sentient singularity versus a pseudo singularity, which is different. When a company falls, or is I don't want to say dies, but like when a company goes under, people are just like, okay, now I'm going to continue doing my own thing. But that's not true of like a marriage or like or a cells within the body. Like your body, or you are not a corporation, and that the cells are your workers. That's a pseudo singularity. I call like an organism that would be a pseudo singularity, like probably most plants, or things you can chop in half and it just makes two of them instead of like it ends the one, or like planaria worms. These beings are like, I call them corporisms. They're an organism that's a corporation of cells. They're not a singular being. They're not an assembly within another singular being, an assembly of sentient beings within a single sentient being. That's not what they are. That is what you are, but it's not what most plants are. I think, again, you can't know because you can't know the sentience of another, but it's shared feeling that is what causes the unification and shared fate.
You can describe these fluctuations as the thing that...
Anyways, I hope that is interesting. Let's let him go a bit more and see if he
Those
says.
three things are very important. And I think when you look at different systems, you can actually say, but all
different people. You can say students, right? So you can say, well, yeah, has a very good learning efficiency. I would say he's more conscious, and this has a very bad learning efficiency. He's less conscious. But again, this is just a definition. If somebody
I hate the definition, but it doesn't matter because that's why I use the term sentience. I think if Curt had asked, "Is the universe sentient?" it would have had a different answer, because you can't say more sentient or less sentient. Does it have feelings or not? Is it someone or not? It's not. Is it more conscious or less conscious? That's why I don't like the term consciousness. And it's not that it's a bad term, but it's not a synonym of sentience. That's my point. And it's not, and it's very often used as a synonym for sentience, and he's not using it as a synonym for sentience. And the way that he's using it here is just kind of like computationally efficient. It's like Curt wasn't asking him, is the universe computationally efficient? He's asking, is it someone? And then again, to go back to when I said, earlier, the Vitaly, when he's saying like, I have my philosophical hat and then my physicist hat, and they're not really intersecting. You have to keep them separate. No, you can't keep them separate. And he says in this clip that I just showed a few minutes ago, he says, I'm bringing a toolbox to a bunch of people that have assumed definitions of words, and nothing in my toolbox is consciousness, but I'm trying to explain consciousness with my toolbox. This is exactly why we need a term. We need to include things that are super subjective concepts like sentience. There is no physical place to point to of someone's someoneness. There's evidence. We can get better at predicting evidence, like in the experiment idea that I have, but it's always going to be evidence. And but we don't need to say, but that doesn't mean that you say, oh, well, there's no actual, I'm not bringing consciousness with me in this model. You kind of have to. And I'm using consciousness there as a synonym for sentience. Someoneness. You have to bring someoneness into this. And you do, really, because you're the one presenting the model. But the thing is that you have to bring the other side of that equation too. There's a reason why solving an equation makes them equal, is basically by making something, recognizing the equality of across perspective of the same structure across two different perspectives. 7 is the same thing as 4 plus 3. It is. It's it's about recognizing two different perspectives of the same structure, which is a 7-fold symmetry structure. And that's really, really philosophical, deep, math thoughts, philosophically deep mathematical thoughts. But that's what is going on. And that's true of everything that you're trying to understand. Is just about getting a proper picture of everything that you need to, that's relevant but from a different perspective than you currently have. So it's everything that's relevant in 3 plus 4 is 3 and 4. And I need to figure out a way to perceive it as kind of maybe externally, which is just a different perspective from internally, which would be 3 plus 4. And then, but in a way that, incorporates all the relevant information, which is really what understanding is. It's context. Think context is information. And so incorporating all the relevant context, 7. So, my point is that that kind of idea is relevant to also how we have to recognize that the sentience of ourselves is mirrored on the other side of the equation by sentience again. There's someone on this side of the equation, there's someone on that side of or someone on this side of the function, someone on that side of the function. And I said this was like the most beautiful thing I've ever written in my life. Probably will be the most beautiful thing I ever have written. And it's kind of relevant to this. And it's this. The search for truth is the search for universality. The search for universality is the search for symmetry. And the search for symmetry is the search for beauty. But the truest beauty is always the searcher. And the truth of the searcher is that they are symmetrical to the sought, meaning like you are a mirror image in some way of the universe or of existence, which is you are someone. So you have to think, what am I? Like, what am not what is a human being? That's a different question. What am I as someone? What that is probably also what the universe is. It's someone, and it's sentient singularity. It's a singular sentient someone. I don't like he didn't do that in that question. He seems to have failed, at least so far.
That even with your framework, I suggest it has to be a square root of 2 times the first number plus square root of 2. I'm okay with that. So as long as I declare what I mean by then I'm happy.
I understand the first two, but the last one about stability, why does that have anything to do with your intelligence when it could be the universe is changing? That doesn't seem to have anything.
I forgot that Curt said that, by the way, that he just gave that explanation of like, why does your stability have anything to do with you? Like it could be the universe changing. I mean, it could be both, but it has to do with your changing your focus, and that could be motivated by you, or it could be motivated by the universe changing. But it's really motivated by the fact that you are looking at a different part of the universe, regardless. So, but it's a great question. It's like wonderfully insightful question. Actually, I forgot that he said that. That's brilliant. Oh my God, I can't believe it. I'm making a Twister game. Joking. Okay, damn it. My computer is crapping out on me. It's time for a new one. Sorry. I will be watching, but I know I will lose and connect again. My love is with you and your message. Thank you. I appreciate that. Do love what you are doing, friend. I appreciate that you're sharing that with me. I do. Far out, I'm late as howdy y'all. Dude, we're all late. We're all up late. Unless you're on the other side of the world. It's okay. But thank you for showing up. I appreciate it. Please hit the like button. Please share this. And watch Curt's entire interview. It's linked below. I really appreciate that they released this.
With this answer, it will not be as...
He didn't answer the question,
right?
As far as I can tell. The question that Curt was trying to ask, and the problem is that Curt used a term that has so many different definitions that people use, and that's why I don't say consciousness anymore. Unless I'm quoting other people, I say sentience because it's different. It's specifically defined as feeling, which is the definer of someone. If you're not someone, you don't feel. There is no you to feel anything. But if you are someone, then you do feel. It is the thing that defines you. If you start thinking about consciousness as having anything to do with like computation and processing power and intelligence, even, that's not what it's about. It's about, do you feel? Is it a feeling structure? Does it have feelings? If it does, then it's someone. If it doesn't, then it's not someone. And like I said earlier, like only someone can think, even though you don't have, someone doesn't have to think. Thinking is a metaphysical action. Sometimes you can take it, sometimes you don't take it. But you can't help but feel, no matter what. Even when you're asleep, you're feeling. Like you are always feeling. I don't even know how much that stops when you die.
And most physicists will
I don't think it does. Okay.
your biology some and I think it is more visual thinking, again related to
how the second law of thermodynamics is a wishful thinking that it has to be really working. So I don't think so. But the other answer to that is that the fact that observers are very special and should be understood, I think, realized by most physicists who pay attention to two important problems in physics. One important problem is the measurement problem. So every single physicist who actually seriously thought about foundations of quantum mechanics, not the person who is just doing shut up and calculate type of things and like following the manual of the, but who is trying to understand the study problem, will necessarily realize that there is a measurement problem. Measurement problem is about this third postulate of quantum mechanics that is very new, because in classical physics all we need is state and how it evolves. Here you need state, how it evolves, and how it is observed. So that's one. And then you kind of have to say something that maybe there is something an additional to quantum mechanics that you have to describe. Maybe it is an observer. Observer may play a special role. And if that's the case, if you realize that quantum mechanics is incomplete and the measurement seems to be playing a special role, then you are stuck with trying to describe. Now, another problem in physics that comes around and also has to do with observer is cosmology. It's called the measure problem. Essentially, more or less a different problem, but more or less the same complication coming from observers. So if you're trying to assign probabilities to different observations in cosmology, what should be the right probability? We discussed the Boltzmann brain problems. It's a part of it. So you have to specify the rules. You have to describe how to deal with observers. And in both cases, if you actually think about this, the complexity comes from the fact that we're trying to put observer into the system. So when observer is outside of the system, we all know what to do. We know, there's a Hamiltonian, how to describe it. Once you put observer into the system, so this is for more general audience, people know about Schrodinger cat problem. So if you put something and then a Wingers-Forran problem, and so if you start putting observers inside, things start to break. And
is it important that the observer is conscious?
Right. So at this point, no. There's something fishy about observers, but we don't have a model of observers. So once you
I will just show you this. If you go to sentientsingularity.com, you go to writings, and you read this technical description of existence. By the way, I've even changed this since posting this, and I posted this last month. And I update and tweak this constantly, but it basically says the same thing and has for years. But I'm just such a stickler with words, and that's why these streams are 3 hours long. And that's also why I suck at writing, because I'm so obsessive. I mean, guys, I literally will write tweets to my friend, messages to my friends, and I will edit it like 4 times. And like later, I'll like put my phone away and I'll be like, just go about my day, and then I'll be like, you know what? I actually I should have said that a little bit. I could have said that a little bit more clearly and more accurately. I'll go back and I will edit my message. And some of my friends make fun of me for it, and like anybody who gets private messages from me knows this, and it is just because I think that there is a right word always. I know there is actually, like it's otherwise language wouldn't work. There's no true synonyms, and that's actually true. We can, like, if you look up the definition for synonym, it says in the dictionary, words that are have the same meaning or are very similar in their meaning. That's not, you can't have a word that has 2 definitions and maintain coherence in a language. And basically what's really happening there is those 2 definitions that you gave is 2 words that have the same meaning but are different words, or 2 words that have different meanings. Like that's really when you say they have similar meanings or they're very related. No, you just so what? They're not the same meaning, then they're not the same meaning. There's no words that have the same meaning, because etymology is how is how words is where the meaning of words comes from. the coherent meaning of words, the actual meaning of words, that persists throughout the life of the language, not within the moment, the cultural moment in which, we start using a term differently, which happens all the time. We change the circumstantial way of which we're using a word, but that will change as soon as our circumstances social circumstances change. But really what persists is the etymological meaning, because that's its meaning in relationship with other words. And so that's the meaning that persists across language. Gosh, I used to literally have very late night. I remember once I had a conversation with Michael Knowles, and I've said this before, but I'll never forget it, until 3:00 in the morning at a bar about whether or not language was important. And I was arguing the entire time no, because I was you can visualize it. And now I realize that I was just not thinking about this properly. It's like, Tyler, you edit your text messages to your friends 3 or 4 times after sending it. You definitely think language is important. But yeah, it's just funny. But here, the point is this. He's saying, Vitaly, we need observers, a model of observers. And Curt says, but don't observers need to be conscious? And Curt is again saying observers are don't they need to be someone? I think this is what Curt is saying. If he's wrong, if I'm wrong and Curt watches this, just let me know, because I'm actually curious. But I think that what Curt is getting at here is he's asking, is an observer have to be someone, do they have to be sentient being? It's not just a camera. It's someone. And I think that Vitaly is using the term observer to mean a sentient being, or what I call sentient singularity, or what we all understand as someone. But Vitaly's saying they don't have to be conscious because of the way he defined consciousness earlier is basically has to do with thinking. It's not about you're someone. It has nothing to do with feeling. And he said we need a theory or a model or a definition of observers, which is we need to bring into these models. We always have he's like, when there's an observer in the system, that's what throws everything off, like the measurement problem, and you get weird, stupid things like Schrodinger's cat, measurement problem. I don't think almost anybody who quotes Schrodinger's cat understands it actually in the physics world the way that Schrodinger meant it, at all. And that's exactly an example, by the way, of why I haven't shared the totality of my experiment with anyone, and I will share it with anyone who wants to actually help me with it. But is because of what happened with Schrodinger's cat. It's all these people, like Sean Carroll, thinks that he understands it. Maybe he does. I'm just using him as an example. I don't remember his definition, but people think that it means that the cat is alive and dead at the same time. And this is a linguistic problem, and it's also a problem that probably Schrodinger used the wrong words maybe, but Schrodinger probably had the right idea in his head to present this, and anybody else who didn't come up with it was told it not with the most precise language that was should have been, or the most true language that should have been used, is not able to actually make sense of it. They're like, no, it means a cat is alive and dead at the same time. It's no. That's not what that means. If it means anything coherent at all. If it does mean that, then it doesn't mean anything. That's a bunch of nonsense. But in quantum mechanics, the measurement problem is the problem of definite outcomes. Quantum systems have superpositions, but quantum measurements can only give one definite result. So wave function in quantum mechanics evolves deterministically according to Schrodinger's equation as a linear superposition of different states. However, actual measurements always find the physical system in a definite state. What this is about is waves and particles. And when you're like, is a wave a particle? Is an electron a wave or a particle? What you're really asking is like, this is what my sentient singularity theory makes sense of, is like, imagine you had to look through a tube and you could only see one point on a wave and you had to take a picture of that wave. It's like, well, what are you going to see? You're going to see it was right there. A part of it was right there. But you can't see measure its velocity, the velocity and position of a wave at the same time. Even a wave on the beach, you can't do it. You can't be like, this is how fast it's going, and this is where it's at the same time. Because one of them is looking at the wave as a whole in how it relates to, where it's coming from and where it's going, or at least where it's going. And the other perspective that you're having is looking at it right there, and you're only looking at a point of it because of the constraint of focus of your own mind. So this is what probably causes this, is that we are not taking the constraints of mind and the structure of mind and itself into account when we are contextualizing the results that we're getting in this circumstance. That, it's like when I say this. Do you see the wave? Yes. Do you see the square? Yes. Do you see the squares? Yes. Do you see the helix in the center? Yeah. It's like what the question you're asking dictates the structure that you're seeing. But if I'm like, if this thing is just going like this, now you try and think about waves and particles, which is like the squares, and the universe as a whole, the square, and like the coherence of that information at the same time, the connectedness of that information at the same time. You just can't. You have to divide it. Just like when Vitaly's talking about intelligence, he's like, intelligence is three parts. It's your oscillation, and it's your speed, and it's your depth. It's like, no, actually, it's probably all of those things are just three different aspects of that you can look at of the process of thinking. That's one process. They're not, and it's like the different perspectives are, you're just viewing three different perspectives of one thing. Same thing is with like a wave versus a particle. It's like, are you looking at a point of a wave where you took a snapshot of where it was at in a moment? Or because a wave is moving, that's by definition. You can't say this is where the wave is and this is how fast it's going, and we can look at those two things at the same time. No. Are you looking at it moving, or are you looking at where it is now? Just then. You choose what's relevant. But you need a model of observers, of sentient beings, of someone's to complete that, so that you have the added context that you need to make sense of why you can't look at two things at once. Kanye. and Vitaly's really right to see this, and a lot of people talk about it, but we don't have theory or model of observers. But that's what sentient singularity theory is. And if you go to writings, again, you're on my website, you see technical description of existence. There's also poetic description, but the technical description, it says right here, if sentience is the nature, meaning someoneness, is of every single fundamentally existent structure, meaning if someone's are fundamental to some things, then a truly foundational theory that unifies and contextualizes all other true scientific theories, is more than just a theory of everything, is a theory of everyone. Sentient Singularity Theory, the theory of everyone. It is a theory of observers. What is a proposal for what structures are someone's in physical existence, in cosmology, in fundamental cosmology, which structures, which would, by then, anything that isn't those things in my like cosmological verse model, like anything that isn't those things would not be sentient. It's a theory about whether or not the universe itself, or whether or not existence itself, is someone, aka an observer. Is existence observing itself? Is it observing other someones within itself? We are observers within something that is it someone? Is it an observer itself that we are within? It's like this, we need a theory that adds all of that in order to contextualize all the other theories that we could possibly come up with that could be true. And that is a fundamental theory. It's a theory of observers. It's a theory of someone's. And it includes definitionally what is someone. It's what are the attributes that make someone someone, an observer an observer. It's someone who feels, because that's what someone's do. Feeling is the definer of observation. It is. It's not thinking. It's feeling. Every observation that you have ever made in your life, I guarantee you, if you are someone, was a feeling. Your observation of yourself, your observation of which are emotions, your observations of light and of texture and of food and whatever has to do with feeling. Even your observation of the passage of time, of causality beyond you, you are feeling the thing that things are changing beyond you, like, or you're feeling that you're changing. My metabolism is gone, not because I'm just not gone. It's definitely changed, and I'm old. Slower to heal. I'm realizing, like, I'm getting older, and like realizing it. I need to like do more to just stay fit than I used to, and that's because I'm feeling the passage of time. Like, that's a feeling, that's a theory of observers. It's why Sentient Singularity Theory has to be the name of that theory, by the way, is because it has to be an ultimate distillation, ultimately distilled description of what the theory is asserting, is defining, which is sentience and singularness, some oneness. You're not some two. Someone. Why are you someone? Because you feel. It's just inevitable. It's funny, but it is. All right. Yep. Motion is key. Everything is emotion. Time. Everyone is moving. That's what it is. And you're in someone, and they're thinking, and they're thinking. There is also the same as acting. If you're inside a universal mind, like, it can't act outside of its body. It acts, or outside of its mind. It acts within its mind, because there is nothing outside of existence. If existence is a mind, is a single someone. Everything has to be done internally. So, God's thoughts are his actions. There's no difference to God. There's a difference for us, but there isn't to God. I will leave you with this. Lorentz has been abandoned. Relativity before Einstein. Meanwhile, CERN does not think Lorentz should be. I don't know what. Well, I know that name, Lorentz, but I don't actually know what you're saying. Lorentz, Dutch theoretical physicist, derived the Lorentz transformation. Yeah, I'd have to dive into this to know. Anyways, let's see if there's any more clips. I think that's it.
Okay, let's. Some people claim yes, consciousness is important,
and they have their own definition. I say it's important to model observer. So if you want to put it inside in the system, then you really want to model how it behaves and model not just saying, well, maybe some kind of emergent phenomena of biology will happen and maybe some kind of wave function collapse will happen. This isn't going to work if you're trying to do the calculation. So my answer is yes, observers are very important. And that's why you really have to describe them if you want to do calculations, even separately in quantum mechanics and gravity. And more so, and maybe because those two problems persist in cosmology, where is the gravity, and quantum mechanics, where there is the measurement problem, maybe the solution is actually try to understand how observers work. And then once you understand that, the both theories may some kind of be unified, and their observer would be models as well, because it seems to be the problem with all of the with both theories. Which again, you can certainly put it under the rug, you can stop to ignore it. Maybe elephant is in the room is everybody knows it's there, but we're trying to look the opposite way. And I'm as you said, like I see the elephant, I say, well, it's there.
At what point do you imagine entered into physics? Is it at the Planck epoch? Is it prior?
So in this model, everything is conscious. There are observers everywhere. Every subsystem is an observer. Some of them are efficient observers. They have efficient architecture, so their loss function, falls down. Some of them are stable observers. They've already reached the very low value of the loss function, and some of them are not stable, and they also always fluctuate out of. So any subsystem, because the entire the building blocks in this model are neurons, and they come with the trainable and non-trainable variables. Because of that, everything is learning. So everything in the sense is observer. Just some observers are capable of doing and asking perhaps more complex questions than others. So maybe, although we don't know, right? Maybe inside of electron there is whole complex neural network that has already solved the problem of quantum gravity and is just looking at us and laughing, saying, "Well, guys, I mean, it's simple."
Yes,
maybe.
And therein lies the problem: is you can't say everything is conscious. Which structures are someone's, and which structures are just some things? That's the question. And it is what Sentient Singularity Theory proposes as is an outline for, which is the only theory that I know of that does this. Every other panpsychist kind of theory says everything is conscious. No. That's not... That idea is not actually fruitful, clearly, because a lot of people have it and they get to it because it seems to be inevitable, which that ultimately that fundamental existence must be fundamentally sentient or someone or conscious or whatever you want to call it. I mean, it's really sentient is what you have to call it, or someone. And if you want to be accurate. But the thing is that and then there's also like someone's within that system. That's us. But what else? And where's the chain from what Curt's really kind of in some way asking is like, where did sentience first, or what structures within the cosmos are where sentience or where someone are the first someones? And within the cosmos, in Sentient Singularity Theory, there's existence itself, which is sentient. You could say that that's also the same as the universe, or you could not. But then there is what I kind of call the universe, which is this being that is created, the second being that's created within the existence, second someone. And then within that second someone is a bunch of other someones. And it's basically got this quasi-periodic fractal pattern of stacked holonic structures, as is written in my right here. Sentient Singularity Theory can therefore be understood to describe that existence itself is a single universal sentient being that is producing an infinitely growing number of additional sentient beings within itself. These additional singularities of sentience or self-aware beings are arranged into a nested quasi-periodic fractal pattern of stacked holonic structures. Composed, and then it goes on. I've actually kind of edited this since in a version that's not posted yet. If sentience is the nature of every single fundamentally existent structure, Okay, wait, no, I already read that. Sentient Singularity Theory characterizes the fundamental building blocks of the cosmos to be sentient beings. That is exactly the language that Vitaly just used, by the way, the fundamental building blocks.
Is
Is it at the Planck epoch? Is it prior?
So in this model, everything is conscious. There are observers everywhere. Every subsystem is an observer. Some of them are efficient observers. They have efficient architecture, so their loss function, falls down. Some of them are stable observers. They've already reached the very low value of the loss function, and some of them are not stable, and they also always fluctuate out of. So any subsystem, because the entire the building blocks in this model are neurons, and they come with the trainable and non-trainable variables. Because of that, everything is
are learning structures. The fundamental building blocks of the universe are learning structures, which are someone's. Only someone can think, but you don't have to. You can choose not to. But all someone's feel. So they're the building blocks of the cosmos to be sentient beings. Attempts to display how space-time, matter, force, and all other physically observable phenomena are generated by the actions, perceptions, cognitive processes of interacting, nested sentient beings. And if you look at kind of like my model of under models here, and you're just like here, this is what I am proposing are the sentient structures, starting with a hadron, going to here, and then it replicates within itself because you reach a constraint of oneness again. But this is a model of this same. You can see here, it starts here with a quark, which is a force point, and then it goes to hadron. This is not a sentient being in my model, but this is a sentient being, and this is like a piece of that sentient being. So the cosmos itself is a single sentient being. This is just a piece of it. It's like a finger. And then within it, it starts to create hadron, first sentient being, a proposed sentient being by me. Atoms, molecules, cells, organisms, families, which are aka marriages, castes, some marital lineages. It's like a different, it's more defined than it seems. Castes, again, more defined as it seems, or tribes, same thing. And then technology, which is like an AGI or technological sentience, which is basically the internet waking up. And this is a proposal. I don't know if it's true, but these are the structures that I'm proposing are sentient. Some of them maneuver via lineages, and some of them maneuver via individuals in relationship with each other. And it's the chain that then replicates and replicates and replicates within itself. So it makes another one within itself when it reaches this point. That's my prediction. We don't know. We got to see. We're only right here in this process. And we're not done. So that's the difference between sentient singularity theory and other theories is it is defined by the proposal of what beings are sentient and also what is the defining attribute of these fundamental structures that are sentient. Like it's in the name sentience because it has to do with feeling. But if you're like, it's an observer, is it conscious? Is it not conscious? Is it an observer or is it not an observer? It's like, no, we're talking about someone. And again, you got to incorporate the understanding that comes from super subjectively understood concepts, things that everyone knows personally firsthand to be true and truly knows, which is when I say someone, you know what that means. But if I say consciousness, you don't. Maybe you know what that means. Maybe you don't. If I say observer, maybe you know what it means. Maybe you don't. If I say sentience, you probably would know what it means. And if you look it up, it'll probably tell you exactly what I mean. But if I tell you someone, that is something you definitely understand. And I'm going to call it. I really hope that was good. I hope you guys found value in it. I really like that stream that Curt did with that conversation that Curt uploaded with Vitaly. I really appreciate, all of you who are here. Please hit the like button. Please subscribe. Anybody who is more interested in my experiment that I talked about and who is interested in potentially helping that get done one day. I don't even know if we have the technological ability to do it. I don't even know if it's possible to do it, but conceptually it makes sense. I'm happy to go into more detail about it with those people. But I think Vitaly is onto a lot, and it's great to see that this is where physics discussions are really starting to go, and this is where they have to go, or they will go nowhere. This is the only place they can go. And I really think that the fact that Vitaly stated that we need a theory of observers to really do any of this stuff, to unify quantum mechanics and general relativity, to unify, to figure out like and contextualize the results that are causing like the measurement problem, to even start to make sense of like what Schrodinger meant with his, cat in a box. You need a theory of that is a theory of everyone, of someone's, aka observers. But thank you, everyone. I know this was longer than I planned. Anybody who's still left is the real one, and I will talk to you later. Memes, what's up? I don't know if you just arrived, but this was a good one, man. I will talk to you. We need to catch up sometime. So, all right, everyone.